Alright, I gotta change the thumbnail, but I'm too lazy to take a new one. And what would I be taking a thumbnail of? How is it? It's good. Nice to see you. Okay, so something we need to talk about is how we're gonna deal with these 3D holes, okay? So we have a current thing, the Jarvis marching thing creates a bunch of 2D holes that we put together to become 3D holes. It isn't very efficient, and I did some research on what we should implement, and I've decided to go for the incremental hole algorithm. We will still be using the code that we made before at some level, because it basically turns our triangulated mesh into n-gons, with coplanar faces and stuff. Is that useful? Maybe. I think maybe at some level it will be useful, but right now I was like, okay, so how do we do this? And so I did a bunch of research on it. So before we get to GJK, we have to make 3D holes, okay? And right now we don't have 3D holes. We have 2D holes that we're treating as 3D holes, basically. Okay. So first of all, what I'm going to do is I'm going to make a complex convex mesh instead of a concave mesh like we had before for testing things out with. And all we're going to do is try to get the whole algorithm to work rather than messing with all of this coplanar, getting these polygons and clipping them. Instead of doing any of that, any of the whole decomposition stuff, what we're going to do first is just try and get the 3D convex hole working, and then we'll figure out how to decompose it, because really the pain and the suffering that led to that we went through yesterday is painful. We did build a BVH yesterday, and that's going to be useful, because this BVH thing is obviously we're still going to use it, right? So this is very good. Am I using Helix? I am using Helix. I am indeed using Helix. Helix is good. Okay. All right, so we are going to want to repurpose this at some point. It is, at some level, it is kind of hard coded for the 2D holes, but really, what it should be more about is this holes should really go to a 3D hole now instead of just 2D holes. So we will redefine this later. Those holes will be a separate thing on the struct. We're gonna call it a different thing. For now, we just want to. Well, first I'm going to make a new shape here. So I don't really know how to use Blender, since I haven't used it in a long time. But we are going to, try to make some sort of what's move again? No. Yeah, it's G. There we go. Okay, so we do not want a concave mesh, but we want something, strange enough where we will be able to see what's going on. I want to get a loop cut. What's the thing for a loop cut? It is Control R. Okay, perfect. Okay, we want to get a loop cut, and we want to move this out a bit. Okay, so not concave, but has some interesting things going on with it. That is really all we want. It's not the most interesting thing going on. Like, we can be honest here. We are going to triangulate this in a second. I forget how you're supposed to do this, but that's concave. That is concave. Okay, so this is convex, right? Yeah. No, it isn't. No, it isn't. You need this to come out. All right, that should be good. I think. Maybe I shouldn't have made it so complex, but you know, neither here nor there. All right, we're gonna overwrite that thing, and I will export this to. And we're gonna call it shape, like the other one, and we're going to export it as a triangulated mesh. Yes. Okay, and now when we compile, we should be able to see that mesh instead of the other one. So let's go and see, and we see this. It's not in the right direction, but that does seem a bit concave, don't you think? What's interesting to me though is that we don't seem to have holes. We didn't split. We had try count 20. And then we split on that axis, and then we got right count 20. We got nothing on the left side from that centroid. Okay. Maybe our BVH builder doesn't work as good as I thought it did. I checked the right, this is the left one. Really, there's nothing between -1 and 1, really. Bizarre. I wonder if I hard-coded something that's not true for this mesh but was true for the other mesh. Okay, I want to see what our triangles are like, what our holes are like here instead of here. And maybe we can see. Okay, so we do have holes, as we can see. We do have subdivided into all of our triangles. Huh. Okay. But we don't seem to recurse past the first one. If left count equals 0, then we exit out. So I don't know why left count is 0. We split on Y, right? Yeah, we do. -1 to 1, and then 1 to 3. Let's see if we made an oopsie here. Full centroid that Y is less than split pause. Huh. I'm gonna guess that the centroids are somehow wrong for each one, because there's no reason why a hole should have a different. We calculate extents here. That gives us the center of the bounding box, which may not be correct. How do I test this? Well, I can simply try to check. Yeah, let's try that. Just to see how we're... Okay, well that would be why they all have the same centroid. They all have the same centroid. How is that the case? Let's see if when we emit it, okay, when we emit it, we have a different thing. Okay, so the only thing I can guess is that somehow our indices are not being... Let me see BVH indices. Let me see the BVH indices. It may be... Yeah, we're only looking through 0. So for some reason we're not initializing it. Init mesh BVH. It goes to the mesh holes count. So does mesh holes count 0 somehow? How is that 0? No, M is 20. M is 20. We don't split before this. Oh wait, hold on a second. Oh wait, I messed this up. You're the electronics and telecom guy? Cool. You're working on embedded software engineering. That's cool. That is cool. I love embedded. Okay. So we only check 0 because what does J start at? J starts at J is the first index plus the parent count minus 1. Okay. So it starts at the end. Unless we have a duplicate. Let me try I itself. Because I may be changing while the index isn't. Oh no, it is. It is staying the exact same. Wait, no, but then we're swapping the whole. We are swapping the whole. It's just the indices. How do I check this? No syntax highlighting? Am I blind? There is some. It's probably hard for you to see. This is my own theme. I do like using it sometimes. There was a period where I just like kind of didn't like syntax highlighting because I don't know. It gets distracting for me. Huh. Okay, so this formula doesn't work then. If it gets stuck in an infinite loop. Wait, but no, J is decreasing every time. J is decreasing every time. So every time it should be going against a different one. Like this is never gonna reach. That's the whole problem. Yeah. So we swap I with J. Alright, the only way for us to know is to actually check what I is afterwards. Because otherwise we're just kind of shooting in the dark. Yo, what's up, Lily? I'm running PyText just for Qtile. I don't know how to turn them on. It's taking hours. That's ridiculous. Yeah, I have no clue how to fix that. So that sucks. Why is it taking for hours? What is it supposed to do? Does this swap not work? Maybe it doesn't. Maybe it doesn't because it's a void thing. I've never done it with a void pointer, or maybe I have. This should be fine. But since it's just indices, then we can just do this. Alright, let's see if this works. Am I a top or a bottom? I guess a top? I don't really, there's not a lot of, combinations, You're famous on Twitter? That's crazy. Wait, so this is still happening? Why? Why is it not swapping? Okay, they aren't swapping. Hold on. Oh my god, I'm so stupid. I'm so stupid. What the fuck is wrong with me? What the fuck is wrong with me? I have a problem. I have a problem. I have a problem. I don't know what's wrong with me. What the fuck is my problem? There we go. Alright, let's try it again. You put me onto Helix? I'll always be channel number 1. Yeah, I'm glad you like the Helix stuff. Alright. Let's see what we have. Not too bad. I think that over here there's a little bit of fuckery going on, you know? Not gonna lie. Does seem to be some fuckery going on. That did fix it though. So I'm relatively happy about it. I don't know if it's fixed. That boy is stuck. You know that video? Stuck. That boy's stuck in time. Okay, there we go. That's what we want to see. I think. It's kind of hard to tell. It's probably chill. Oh yeah. Because this is the only one that has one. There's probably a reason for it. How the hell did you use Haskell as a text editor? What do you mean? Oh, you put it in the text editor ranking. How do you rank it along with your other text editors? Haskell. I can't imagine that it made like for the greatest one of all time. Yeah, I have no way to actually tell if this shit works, really. We're just gonna pretend like it does. It seems like semi-correct. Good enough. Anyway, we fixed it, so I don't have to worry about it anyway. Haskell transcends functional programming. I think it just is functional programming. Oh yeah, this doesn't even work. Oh my god. No wonder I'm stupid. It doesn't let you do this. Okay, so this is, let's just do that. Okay, you can do this with a macro, by the way, but I'm just stupid because you have to have a type to go into the macro to cast it. We're not going to do any of that because I don't give a fuck, but how do you multiply them? I don't know. I just do Shift C. I don't know how to multiply them. That's great. There is a way though. There's a way for something like that. Okay. let's move on with our lives to all of this. So I did a bunch of notes. Okay, I took a bunch of notes, and we're gonna figure out, is there a space binding? Why would you want a space binding? Do you like space or something? Okay, if it's too annoying for me to use this theme and you hate this theme, then I can change it. Because I know that there were some people that were like, when I used this theme, they were like, oh my god, this is fucking awful. I can't fucking read. Oh my god. And so, shift isn't really accessible. Okay, well, that's exactly what they told me about cardiacs. I like cardiacs. I need my text colored or I'm blind. Okay, fine. I hate all themes that have like too much. This is why I like this theme, because I like how it's just like very simple to read. It's just like I don't like a lot of themes. Because a lot of themes are just like so many fucking colors I can't fucking read. This one's alright. This one's mine. It's alright. I based it off of the colors from the Utena movie. Actually, I didn't base it off of it. It's just, you know, I picked the colors out from like my favorite stills from that movie. So the colors are really good in that movie. Bro, all these are fucking shit. Do you guys use this? All right, we gotta finish. We gotta stop doing this. I gotta code. Okay, we're doing one of my themes because it's my theme. No, we aren't. Dude, like seriously, dude, like seriously. I'm not using capuchin, bro. That's so normie. That is so fucking normie. This is criminal. Okay, we didn't come here to see this. Dude, I really want to go back to my theme, dude. Tokyo Night is okay, but it's so basic, bro. It's so basic. No, Grovebox is fucking normie as fuck, man. And it's just like it all blurs together because they make the background so toned. I like dark backgrounds because then, you know, the contrast makes it actually readable for me. Rose Pine's alright. No, they have this purple that you can't fucking see, man. This is why I like my theme, because there's such insane contrast that you can see everything, you know? Like, you can see fucking everything. Solarized? This is disgusting. Why is this gold on blue? Oh my god! The fuck is that? I'm sorry. We're going back. I literally I can't with this shit. All right, let's lock in. Let's lock the fuck in, okay? So we need a point cloud of deduplicated vertices. That's important. It needs to have deduplicated vertices. Luckily, we don't have that, so we need to actually do that. That kind of fucking sucks. Okay, that kind of sucks. So a couple ways we can do that. We can do that, you know, through a hash, you know, table or whatever. I think for now we don't have a lot of vertices, so all I'm going to do is I'm just literally going to fucking just get rid of them. Just straight up get rid of them. It doesn't matter. That's what I think I'm going to do. How do I do that? I don't know. I don't know if I want to start from the kind of decomposed 2D holes. or if I just want to start from the raw triangle vertices. Well, let's make it a different function. Let's just make it a different function. We will call this decompose, and we'll just decompose the mesh, but we aren't actually going to do like a full decomposition. All we're going to do is deduplicate the vertices, and we will we're going to cast vec on the mesh tries. Studio Black. Cascadia Mono. Yeah, Cascadia Mono is alright. And people hate it. And you remove cursors, it's comma. Okay, so we're just gonna loop through all the triangles and loop through all of the points on those triangles and then push them. It's important to, what we're gonna do here is we're gonna have another vector here called vertices, and this is gonna be the decomposed point cloud of vertices that we're gonna use. So we want to loop through. This is kind of disgusting, but we're going to loop through in, you know, double loop here. And we're going to compare against every other point from every other triangle, check if they are the same. We can do a more, you know, better thing here. You're going to try different console fonts. I don't remember what font this is. I think it's Mona Space something. I fuck with the Mona Space fonts lately. I think they're really good. So we have all of the triangle points, and now we need to go through. Unfortunately, it's like a cursed nested loop here. This code isn't going to be the final code. I just want to get this out of the way for now, because we need to have every point deduplicated. Okay. Triangle pointer and try 2 equals hold on a second. Let's make sure that we don't compare the triangle twice. We just have to check if J is I. Continue. That's that simple. And now we're going to go like this, and then if try P dot try points P dot pause vec3 equal with that, and try 2 points P2 dot pause. This is disgusting code. Got my sub? Thank you. Thanks for the sub. I gave up on X Libre. I have no clue what that even is. You liked my chess engine video? Yeah, I'm surprised you didn't see it before. That was kind of like the thing that I did in life. You know what I mean? It was all leading up to that point. Why are we saying too few arguments? Oh, we have an epsilon. Okay, well, let's just put in 0.001f. Okay. Then we want to deduplicate the points. Yeah, so okay, so here's what we will do. We will have a bool unique equals true, and then unique equals false. We will break if not unique, break. Now you could use a go-to there, but people hate go-to, so we won't write it. Okay. Alright, so we break out here, and if it was unique after all of that checking, then we will add it to the vector. Up here, we want to get that vector. We want to init vector first on the mesh. We are doing vertices. We're going to initialize it to I mean, there's really no need for it to be a vector. It's kind of just going to be slow for no reason. Why not just make it an array? Because we're just going to allocate it once. Right? Nah, but you might have a lot of duplicated vertices. So do we want a vertex to have just position, or possibly normal as well? Okay, yeah, let's deal with that. Told my mom that I'm atheist, and she said no, I'm not, because I got baptized. I also got baptized. I had communion too, or whatever. That shit was awesome. Like wine, bro? How is that legal that they do that? That's fucking crazy to me. I'm thinking we make a different struct for this. Oh, I already have a point struct. She can't force you to be atheist. Bro, the older I get, bro, I think religion is based. I don't believe in it, but I think that religion is kind of based. I mean, like, obviously what they've done to religion is kind of shit, but I don't know. I'm all Dostoevskian and shit. I think religion is based. Only half joking. You know, we shouldn't be using this for a draw buffer. We really shouldn't. Really shouldn't. It's just going to be vec3. Why is mesh vertices passing vector? Oh, that's why. Dude, like, okay. Okay, we initialize the vector. Okay, so we want to vector expand by 1, and we will put in we will set point equals okay, and to be like, let's just like write it like a good person. You know what I mean? Like we gotta really be honest here. We need to write this properly. Okay. Nice. So now we don't have to do this, and we just set it to A. Beautiful. Why is there no color? Okay, fine. Like Jesus Christ, dude. Like people. Okay, so let's look at other people's theme. Like this is so fucking. There's too much shit going on. There's too much shit going on. Like how are you supposed to read? Like this is like cotton candy fucking bullshit all over the place. Like how are you supposed to read it? Like this is the shit that I like. Like just like very very simple. Like I like what is that? Sorry, I said that really loud, but dude, like shit is just so there's too much shit going on. It's so fucking distracting. Like just so distracting. I'm about to put this on one light. No, I'm joking. I'm joking. I'm joking. Sorry for the epilepsy, by the way. They want me to change it so bad. Okay. We have to decide. We have to decide on changing it. Bro, flat white is kind of gas. What do you guys think about flat white? Mining box darker? What are you talking about? Dude, flat white is kind of gas, no? Mining box? What are you fucking talking about? Talking about Grub box? This shit is like rustic bullshit. Mining box darker. Bro, I don't know what that is. What is mining box darker? That's not a real thing. You're lying to me. This one's kind of gas. I kind of fuck with this. But it's light theme, so everybody's going to complain. Alright. We got to decide because I want to actually write code today. So we're going to put this on Tokyo Night. Okay? And everybody's going to be happy with it. And now everybody can just be happy with it. Grub box darker. I don't like grub box. I don't. I really don't. I really don't. I don't like it. I don't like the greens. It's just not good. No one complained about the theme on my chess engine video, which was this. This is my theme. I fuck with this theme. It's just, it's just the code, It's just you and the code. That's the way I like it, Okay, anyway. Or we decompose the mesh. We officially decompose the mesh. So at the beginning of incremental hole, we'll just call decompose on this mesh. Okay. So now we should have deduplicated vertices on the exterior. Do I use a formatter? I don't know what a formatter is. I mean, Gruber darker. That one was even worse. That was even worse. I mean, actually, this isn't that bad. I just hate yellow. I really hate yellow. Like all over the place. Like it's like working in a factory. I don't know. I'm picky when it comes to themes. I'm picky. I don't like a lot of color. Because you know, it's just it just like if we're gonna get all pissy about dust, I might throw it on Eiffel, bro. I might just throw it on Eiffel. I use style code along with some custom. Oh yeah, that stuff. No, I don't do that. I just write code the way that I want to. I don't know. This isn't bad. It's not like that bad. But at that point, I mean, just throw it on Eiffel. Call it a day. You know, like this is pretty much just Eiffel, but with more colors. I don't like how syntax highlighting makes me like read code. Like it makes me read it in like chunks rather than actually like read it. Like this is so hard for me to read. Like what the fuck is going on? At least to me. Like the booleans are the same color as this, and so like your eyes follow it weirdly. Like I would rather just have no syntax highlighting and have to actually like pick it out myself. Like that's what I that's what I like. Like if I go to like Eiffel, this like makes me read it like regularly. You know what I mean? Like this just like it just makes sense to me. And also my themes like Utena, for example, what I have is I have a system, right, where the darker colors are on the left and then the lighter colors are always on the right. And the reason why is because I like to read from left to right. Like it's that's like how I make my themes. Would love a series in game programming and C. Yeah, I mean, I think that the streams are definitely like probably the, you know, as close to that as I'd get, but maybe eventually I'll condense it into videos. I'm kind of lazy with the videos. What theme would I recommend? This one, my theme. Love from India, love from here, love from the USA. Okay, so we decompose the mesh. Well, this isn't really decomposition. We just deduplicate. That's fine. Okay, so moving on into the actual formula. This is the whole point of having the split open, is so we can read from the notes. Okay, so we have our point cloud of deduplicated vertices. The mesh must be convex already. Okay, so that's fine. We already made a convex mesh. We'll decompose it later. Before adding a new face, check the length of the normal is less than an epsilon so that we don't get a degenerate face. Okay, absolutely, that's fine. Okay, so we want to pick a random point. Then we pick the furthest point from that point. Then we pick the furthest point from that edge. Yeah. And then we should have 3. Right, and then we pick it from the triangle, and we have a formula here. And then how do we pick the final one? Now we have a tetrahedron. How do I get this again? For each face, if d equals 0, find tetrahedron vert that is not on the face. Is this distance? I think that this is distance. Oh no! This is how we get a tetrahedron. This is how we do it. We need the dist from the point minus a. It's the n. Okay. So before we do this, I have to set up some stuff in types. I have to set up a struct that is going to have. I'm going to port my theme to light mode and call it might. I think that would actually work. Like, this might be good in light mode if you like inverted the colors. I feel like that would kind of be cool. Also, it might be like the compression or something that the color doesn't go through. That there is like gradation, right? Like this is darker than this. It's kind of hard to see, I guess, over the stream, but okay, anyway. So we have a simplex. That's the whole thing that we're building here is a simplex. And so we're gonna have a vec3 points to 4, right? Because 4 is where we're going to with the tetrahedron. We're gonna say that a lot today, so I gotta get ready for that. I have an int point count. Let's just call it count. That should be it. So we're always going to have a at a is always going to be the newest point, so that's important. We're gonna call this, instead of try point, we'll change it later, but I just want to have d there for this. Okay, what else do we need on this? I don't think we need anything. I don't think we need anything. We might want to cache the normals or something between steps, but that's kind of an optimization thing. Okay, so the first thing we have to do is pick a random point. I don't know if the random point matters. I think you want to pick the lowest point in some axis. By some axis. So let's pick. Let's just pick. Let's just get an index to pick lowest point. We will find on the mesh. We will find on the mesh abb.extents which one is the longest. I already have code that does this. Let's just literally do the same thing here. Okay, copying code isn't what I want to be doing, but for now it's fine. We're going to replace parent with mesh. Okay, and then we want to find the point with the lowest axis on the longest axis. Now, there's kind of no good way of doing this. You kind of would love to just like walk the BVH, but doing so would require walking the BVH. Do we care about picking the longest axis? I think that we do. This is kind of annoying because I have to switch here. And then that's we're professional. Just asking Y and C with all this hype around Rust. I don't think that new languages, because of their age, have good compilers. And so I don't really trust when people say, you know, that this is as fast as, you know, languages that have been around for forever. Now, is Rust probably a good language if you have like a large team of people? Probably. It leads to cleaner code practices, sure. Now, is it better than like C or C++? Absolutely not. I don't think that it's worse necessarily, but, you know, that's just my take. It at least has merit, unlike, fucking Zig or whatever. Write a manifesto about Zig. I mean, Rust is fine. Like, it's not Zig. Um, Sorry, I'm not talking like a ton today. I hope that that's not like, the most annoying thing in the world. It's just kind of hard to explain what I'm doing here. I'm just like finding the lowest vertex in the point cloud. Um, this isn't like the nicest thing I've ever written, but what's a hole? It's the thing that we use for collision. It basically is the outline of a mesh, that we can test our bounding boxes against. That's the point of it. How do you search a buffer? Uh, backslash, and then you do space backslash, and it does the whole file system. Why would I move from C when everything in is there? Yeah, that's also a thing. Yeah. Yep, it is for collisions. Okay, so we just want index equals index. Wait. What the fuck did I just write? Okay, we're just gonna return index. Okay, so find, what did I just call this? Pick lowest point. In lowest index, and we will get our first point. We want to, at the beginning here, create a simplex s. And now our s dot points a is going to equal, well, we want to get down here vec3 points equals, since when are you game programming? I wouldn't consider necessarily what I do game programming. I think I just do like general 3D programs, but I also did the chess engine, right? But in terms of like 3D programming, probably like year and a half. I hope it's not 2 years, because that would be embarrassing. C is widely adopted for game engines. Yeah. I don't really know if like, because I build everything kind of from scratch in C anyway. I don't really know if like Rust would change all that much in general. I just think in general, when it comes to compiling a language, it is so much more trustworthy to be compiling C or C++ to Rust. Like, that's just how I think about it. Because it's just been around for forever. There are no, weird things about it. That's just, what I believe, though. Okay, we have our first point. We have our first point. So now we need a loop, a while loop, that goes through all the points. I don't know what to call this. We're just gonna call this okay, while L. We want to switch on S count. And now we're gonna have 3 cases. I don't think that we need the 4th case for just a point, although yeah, why not? So I don't think that we have 0. It can't be 0 because we're always gonna have the first point, right? Because even if we go into this, we don't even have this, do we? Sorry, I'm thinking. I don't know, I feel like Rust would just add more to get used for me. Yeah. It's really, Rust isn't that bad. Like, I programmed in it for a bit. It's fine. I made a chess engine in Rust. But it's like, there's a lot of friction. I mean, but my argument is that even beyond the language, I don't like newer languages because I don't really trust just the... You can just type C to do a new... That's what I just said. It's Shift C. What are you talking about, Lily? That's the same thing as C. As capital C is Shift C. That just tilted the fuck out of me. Hold on, I gotta recoup. Alright, let's recoup here. Okay, so if we just have 1 point, then we need to find the furthest point from that edge. So let's make a new function. Or furthest point from that point. Actually, yeah. So let's just actually get the simplex in here. And we'll just move this inside of there. That'll make this a lot easier. Okay, so if it's case 1, then we need to just find the furthest point from that point. Which we do by iterating through all of the other points. Rewrite this in verse? Just set in stone? Yeah. Could rewrite this in Haskell. No, I'd argue that Haskell would introduce some difficulties because you don't have loops in Haskell, so how the fuck are you going to write a loop? That's my argument here. Now, if I'm crazy about that, then you can let me know, but... Okay, so we need our points. And now we want to get... Do I have dist? I do have dist. I also have dist squared. I think you just want the regular distance. We're just going to do dist between s dot points A and points I. And now it's mad because I'm initializing vec3 with something. Okay, so here's something that I noticed. I just don't want to be so, mean here. But why the fuck in Windows Terminal can I, for whatever reason, not have inline hints turned off and instead up here? Why? Why does it not work? So then you write recursion, you dummy. Okay. Yeah, just write recursion, dummy. Yeah, definitely. Oh, it's float. Oh, yeah. Okay, I'm a bit stupid. It's all right. Probably fucking really bad. I don't know. That's what we're gonna leave. Because if that gets triggered, then you probably don't have any points on the mesh. Probably. I don't really know how it works. But that's probably, you probably don't want to, that you don't want to do that. You don't want to do that. Stop helix? No. Okay, so s dot points B equals best, and s dot also we need to be passing a pointer. I just realized that. I thought that we could be all fancy and just, we're not gonna do that. We're not gonna do that now. Okay. Okay. No. Our B will not be best because A always needs to be the newest. So newest always goes into A. Based on what we have experienced. Starting ARG, I'm all right. I don't need internet famous. I don't need to be like the backrooms guy. The backrooms guy. Okay. So that's the line case. And now, if we already have a line, we need to find the furthest point from that edge. Oh, also, this is going to take in a vec3 dir. That's important. Or does it matter? Because in here, we can figure out the dir. Let me think about this. Yeah, maybe we don't need to. Maybe we can decide the direction in there. I don't know what the dir is. We need to calculate the dir. Furthest point from that edge. So you don't have a dir here. You just do this cross, and then you find the distance. For each point. I thought that that you had to have a dir first, but who are you? Would you recommend setting auto change directory in Helix? I don't know what that would entail. The thing is, I don't think that you want to... This is hard. Like, so because, like, the file picker is from... So you have based off what file you edit and stuff. Yeah, that's probably cool. I don't know. I don't use a lot of like folders and shit, to be honest. In my projects, I kind of usually keep things in, where they need to be. And I'm just used to really like searching for whatever I need. I'm wondering if I need to delete the vertices from the master vertex list as I go along. I'm not sure. I'm not sure. Wait, hold on a second. I'm fucking so dumb. Wait a second. I oh my god, I'm so fucking stupid. I'm so fucking ill. Oh my god, I'm so stupid. I'm so stupid. I was mixing up the GJK simplex logic with this. This is actually just like a straight up hard coded thing basically with our points. We don't actually have to do that in a loop. I was getting ahead of myself. That's something else that I need to do. So really this was basically really getting ahead of ourselves. So really we don't need a simplex at all. What we need is just our whole vertices. And so I want to change the type for convex hole. Okay. So let's just have one convex hole on the mesh. For now. We're just gonna call it hole. Okay. Because we're not gonna worry about the decomposition yet. So we'll just be using mesh hole. So we'll have convex hole. Okay. So we will be moving around the vertices on that structure. We'll be adding the vertices to that structure. And this structure has point count and points. It doesn't have... It's not a vector, which I want it to be a vector, I think. That sucks. Let's just bite the bullet and do that. It's gonna cause a lot of errors in here, but right, Cosette font. I think it's cool. It's kind of like Dina remastered, right? But I don't know. It's hard to read. I prefer, if I'm gonna do that, I prefer the fonts that I used to use, like the Trident fonts and the old school fonts. You should try those out, yeah. So instead of, we want to init vector for this whole points. Are we still not a millionaire? Segway UI? Yeah, that's a good one. That's a good one. How am I not a millionaire? It's so funny. Okay. So now when we get our first point, I want to use the first point. So okay. So now we have our first point. Now we want to check to get the furthest from that point. We want to check against against P. We should probably put this in a separate function that just sets it up, huh? Just sets up the first 4 points. Oh, you got to number 1 from spamming. Please add a Lua scripting framework to the project. I'm not really sure if it's gonna really be an engine that other people use necessarily. But yeah. This will set up the initial hole points for us so that we don't have to worry about it. So we'll just pop this in there. Just so that we can be clean with it and not have it in a massive function polluting the namespace and shit. Because I just kind of thought about that and was like, oh. Okay. So in this case, this is going to be P2. And then we will do P2 equals whatever our best was. Okay. CC version of Tokyo Spliff. I mean, I don't really work on the same sort of things, but that I'm flattered, yeah. Okay, that's pretty much all we care about. What was next on the list? I hit the DPI button on my mouse, and now I'm gonna be in a bad mood. Okay, we got it back to normal. Okay. Okay, so now we need to pick the furthest point from this edge, which is what we started doing earlier. So we need a B and A, which are our first 2 points. I would prefer not to do I'm just trying to make this in a not shit way. Okay. Expression is not. Oh. Okay. Oh, it's because of this. Okay, well, let's not worry about it then. Okay, so instead of doing this, I can just do this now. Which is, it's actually B minus A, which is the furthest from the. May he have a great programming session. Thanks. This is Arizona iced tea. No, it's coffee. Okay, so then we need to loop over the vertices. Yeah, I was really confusing the GJK method with this. I totally kind of forgot what we need to do, which is never good. Um, um, so now we need to subtract P from A to get AP. And then to get the dist, we do the length of the cross of AP, AB, and then we divide it by the length of AB, which is nice that we can do AB len AB, and so we don't have to compute it every time. I drink Lipton every day. Do you? Oh yeah, we talked about this, didn't we? That you have a lot of Lipton in Australia or something. If cross BACA. Okay, so we're just finding the longest. So we're gonna reset best distance, and if dist is greater than best dist, we will set best dist to dist, and best will equal P. That's simple. Okay, so once again, if best dist is 0, this is probably really fucking bad. I don't know. We'll deal with that later if it comes up. And else, we will vector expand again. And we'll just do P3. And P3 will equal the current best. And then C will equal the current best. Okay, so that's our first 3 points. Drink tea every morning. Bickies but one. What is a Bicky? I hope I'm not supposed to normalize this. I mean, maybe I am. Maybe it doesn't matter. I have no clue. Oh no. If I'm doing this B minus A thing, this is supposed to be normalized, yeah? It's a direction, yeah? Yeah? Or not. No, we take the length here. It can't be. Because we're taking the distance, okay? So it matters. Okay, so here's an edge case, right? So if the cross of vec3 subtract B A C A is it the length? I'm just gonna say the length. This is just an edge case that I saw. All right, last thing here. Biscuits. Biscuits. That reminds me of The Conjuring 2 with that kid that's like, my biscuits. Mom, give me my biscuit. You know? If D is less than epsilon always, the points are collinear. Okay, so this is important. So let's just have a float eps equals 0.00. If bestest less than eps less than or equal to eps. Okay, let's lock in here. Let's lock in. Okay, we need to find the furthest point from this triangle that we've now constructed. We constructed an A, B, and C triangle. Okay, that's what all this is for. So now we're going to take A as a reference point, and we will make a normal here. We will normalize the cross product of got some viewers today. That's surprising. I haven't had viewers in a long time. My word for creating variables and naming them something like, yeah, the N in front of them is kind of weird. Yeah. Your arguments are A, B, and C. No, that's completely fine. Like the naming convention I'm using here is fine. I usually disagree with crazy names. Okay, so once again, we need to loop through the mesh vertices. Okay. For each face, okay, so the dist is going to be different this time. We need to still do this, but the distance is I think it's different here. Because we're dotting. I don't think that this is distance. Too few arguments. Oh, whoops. If this, so if D is less than or equal eps, this is another case where probably really fucking bad, I don't know. Oh wait. No. If D is yeah, if this is always. Maybe D is the You would have more viewers if your project had a Lua scripting engine. Uh, yeah, I think I just don't have a lot of viewers because I'm fucking crazy, but that's fine. We get terminal and see and call it Dusty. What exactly would I be scripting in Lua right now? I'm trying to get collision working. I don't think Lua is gonna help me out with that goal. Oh my god. Is this really it? Is that really just the distance? That can't be. Maybe it is. This just seems like not a lot for the thing. But I guess this is just literally the dist. Okay, so we need to compute the normals. Hold on. We need to compute the normals? Why do we need to compute the normals? Oh, each face needs a normal. Each face needs a normal. Okay, that's fine. Okay, so let's just make, in this case, let's just make a type that has that. Face. Oh, actually, it's just a triangle, right? All of our faces are going to be triangles. Right? I think so. I think we can just keep them as triangles. You say hi? What's up, hi? No need to ban me. I'm not gonna ban you, bro. Okay. So we have our first set of whole points, but I think we don't actually want them. Can I say hi? Hi. I don't think that we want them as points, but rather faces. Yeah, I think that we want faces. So at the end, we can do one of two things. Okay, so let's create the faces at the end then. Let's create the faces at the end. I don't think we need the faces, though. I don't know if we need to keep the faces. I'll just put it on here. Just to be... We're just going to have a vector of faces, okay? Just to be very simple. We can get rid of it later if we don't need to keep it. At the end of all this, what we're going to do is we will init vector for the faces, and we will init it with the size of a triangle. We want to, let's initialize it to 4, since we will always start with 4 points. And we just want to fill this up with information. So we want to get a triangle pointer faces equals cast vec faces. Don't do that. Whole faces. We're casting it to a triangle. Helix is peak. I'm glad you like it. I was trying to convince you for a while. Okay, so we have 4 faces now. And we need to connect all of them. So let's do that first. Okay, so let's calculate the normals. So we need to compute the normal. I don't really remember. Am I stupid? It's I need to cross the B minus A and the C minus A, right? But I have to figure out how to figure out what's going on, what face. So we will do the B A C A first. Let's do this. Let's do this. Let's just do. Let's just get the. Let's get the. Get all the parts, the moving parts ready. So we have AB, AC, AD, BC, BD, CD. So you can get up to speed. I have a GitHub of some of my projects. This project isn't really on there yet. But yeah, you can. I think there's links in the description for those of you that are interested. I have my Linear project and my chess engine up there. Personally. Okay, so we need to make 1, 2, 3, 4, 5, 6 triangles. I think. Technically it's 6. I don't know about the bottom side. So basically, right now there's a triangle, a 3D, basically a pyramid. I'm trying to figure out what I do with the bottom though. Do I split it in half and make 2 triangles, and now we have 6 triangles? Or do I just keep the 4 on the side? I don't know. I think it's 4 faces, though. Oh, no, no, no. No. Yeah, yeah, yeah. It isn't 6 faces. I'm stupid. I can't count. Okay, well, I need to think it through then. So there's 1, 2, 3, 4 points, and in terms of edges, there would be 1, 2, 3, 4, 5, 6. So I am correct with the amount of edges here because we have 6. So that's fine. We do have a redefinition of AB here. Well, I do already have AB. So that shouldn't change. Okay. So N0 should be the same. We are going to AB and AC. That'll be the first one. That'll be the first face. So this one will be A, B, and C. Actually, let's name this. So then we need that's A, B, and C. Then we need let's do BDC. I'm really not stupid. You're clearly really smart. Thank you. I appreciate that. Let's figure out what we're crossing here. So if we're doing AB and AC for that one, now we have B, D, and C. We have to figure out what we're crossing. The good thing is that we have a center that we can dot against. Maybe I'm thinking too hard about this. This is just going to be BC. Is it BCCD or... Oh, I don't know. BC... If the first one was AB and AC, I didn't do BC. So AB, AC, B, BD, BC is the equivalent. We have to do this 2 more times, by the way. So... This is the most painful part, but we're going to get there. We're going to get there. Okay, so now if we have BDC, now we need to start at C. Oh, no, no, no. We need to start at D. DAC. Yes. Yes, yes. Okay, so DAC. If we're going by the same logic, well, if we're going by the same logic, then this sucks. Hold on, am I doing this right? I think we may need something else. If we're starting at D and going to A, then we need to start at D and go to A. So we need DC or DA, DC, which is going to be this swapped. Feeling like distance the closest point on mass. Yeah, that's a crazy function name. That's crazy. Okay, now we need the bottom one. So this is going to be the bottom point. So everything but C. So basically ABD. But in doing ABD, I have no clue what the orientation is because now we're on the other side. Or not ABC, it's ABD. I'm just going to trust myself on this one and go ABAD. And we'll see that. So now, each time we create a normal, we have to check. So for this one, it's point D. So if vec3 dot vec3 sub D and A with ABC, if that is less than or greater than 0, then we need to switch two vertices around. Oh, I can't wait until this is over. Oh, yeah. This is it right here. This is what it's all about. Graphics programming? Oh, yeah. Do graphics programming. It'll be fun. Ah, yeah. I love graphics programming. Are you kidding me? Dude, graphics programming is awesome. Aha. Fuck. So now we need BA, basically. Is that what it is? If I'm swapping them around, can't I just do... This is so fucking confusing. What are those function names? What are those function names? There's so many ways that you can swap these. You could go BC, BA, like, what? Dude, am I... I feel like I'm going crazy right now. Now, for this one, you're going to do A with B. And then if that gets fucked up, then you probably want to do... I don't know how to split them. Find model UUID with instance UID. I'm telling you, you could have definitely done that a different way. That's not right. That is not right. That is cursed. This is fucked. I don't think that this is gonna work. I'm not gonna lie. Isolated and contiguous. Yeah, you do the arena allocation thing. Yeah. Yeah, sure. That's good. That is good. That is good. This is gonna be impossible to debug. Wait, but how is this any... No. No, it's supposed to be... No, this was wrong. This is supposed to be... This is supposed to be... This is DA and DC. Oh, okay. So DA and DC. So this is supposed to be... D... No, yeah, let's just go... Oh, no, we're already doing D there. So then... Let's do, Let's do, God, this is really fucking tiring me out, I'm not gonna lie. Like, I'm at the point of, like, this is, like, really, really tough to think through. I'm, like, having to picture fucking everything. This is really hard. It makes your mind melt. Yeah, it's... So basically what I'm doing here is I have 4 triangles on different faces, right? And so all I'm trying to do is I'm making sure that the faces face outwards, right? So that's all I'm trying to do. It wouldn't be nearly as bad if, like, I had a reference point that's, like, better, but it's kind of fucked. I guess we're going to pick A for this one. I'm not really sure. And that's going to be C. And now we'll go with, we'll do... We'll do D. B, C, D, F, G, yeah. Okay, I don't know if that's gonna work. The normals might just be wrong. The worst part is that we're not even done. We're not even close to done. BLAS before I spawn the recursive tree to push the father node. Yeah, that's a good idea. Okay, so we have to return. Well, no, it's just going to be on whole faces. Okay, so let's just return a bool. And so everything else will return false if it gets fucked up. Alright, I don't think we want to vector expand the points. I think that we just want the faces. So this is kind of pointless. We just want that. Okay, and then we init the vector. Oh right, we didn't even make the faces. So now Rubik's Cube points. Yeah, that's crazy. ABC. Array subscript is not an integer. What? Oh. Yeah, I can't. Okay. Well, I made a mistake there. We're just gonna ignore it. We're gonna pretend like that doesn't exist. That's how Chads do it. This? This is not it. I hope that I'm doing this the right way, because if I have to redo this, holy shit, I'll be fucking tilted. The tricky thing is, okay, I just had a moment. I think I realized something. We could do this in an automated way. Okay. I didn't have to do that. Will just ignore steps and trace. Say goodbye to program. Is the recursion that bad? You know what? You know what? I'm grown up. I'm grown up. I'm grown up. We're just gonna use the try normal off the thing. Yeah. This was all I had to do. Oh my god, bro. Fuck, what is wrong with me, man? They just normally don't step 0. Want 0 on one of them. The feds are dropping an airstrike? Is that what's happening? Did I miss something? Yeah, I live kind of near a military base, so they do kind of like just like randomly fucking go overhead, which is like not very nice of them, but that's fine. That's fine. That's fine. That's fine. This was all I had to do. This is the pattern, bro. I'm just like really stupid, but that's all right. Like every dog has his day. Wait, yeah, I can just. Oh no, but I need to manually put them in. That's so true. You are so true. There was an aircraft sound. Yeah. Been trying to episode just race on forever. Oh, I see. Now you split BVH leaves in 2. Do you split along the longest axis? Yeah. Yeah, pretty much. The only difference is that you're sorting on the way so that you're making sure everything is contiguous with each other. That's really the only difference. There's better ways to split it, but I just go longest axis. At least on the stuff that I'm doing here with this engine. Okay, so let's lock in here. We still need this. So this one is going to be BDC. B. Fuck you. BDC. And then when we swap, we'll swap D goes first, and then B goes second. And then we want to be testing A against B. Now, I don't know if we need to try twice. We should. You can just like do the. If you swap it, you can do it once, right? You don't have to do it multiple times, right? We don't have to like while loop this or something. I don't know. I say that we just keep it simple for now. But technically, we could have it so that it just swaps different ones. Yeah, for now, we'll just do this. I'm getting way too much in my head about it. Fuck, why is this so complicated? Well, I mean, this is why nobody does it, right? This is why everybody's like, oh, collision sucks. Collision sucks. And I'm like, collision is fine, bro. Like, what? How bad could it be, dude? It's not bad. What do you mean it's bad? Collision rocks, dude. One or the other, but not both. That's a Katie split. Yeah, I think it's different though because of how you're. Did you look up some implementations out of BVH, because you're not just splitting in half. You're also sorting an array of indices as you go down. ABD. ABD. And then we want C and A. And you will swap B and A. We're just going to swap once. Because swapping twice would mean that I would have to do some addition and then some wrapping arounding. And yeah, let's not do that. We don't know if it's necessary yet. Okay, so the fucked part is that the fucked part is that this was only to get the first 4 points. Sorting would be smart, I guess, then you could walk it faster. It's not about walking it faster, it's about the speed of building the tree. So that you're not testing against everything. Here's how it works, right? So you take the longest axis, right? And then you split it down the middle. But then you're checking against everything's AABBs, what's in the left half and what's in the right half. And then you're swapping inside of the internal array what's on the left and then what's on the right. And then when you go into the child, then you're only checking what was on the left. Does that make sense? And then when you eventually go into the right child, then you already know what's on the right, right? So you're checking less and less as you go down the tree. Otherwise, you would have to check against thousands of AABBs every time you recurse downwards. So that's the difference. Okay. Okay, we're setting up the initial hull points. So we did that. We have our 4 faces. Okay. First of all, we need to compute the center, which is very simply, we just add all of them and then we divide them. So the center is not going to change. That's the good thing. We do have to add a bunch of things together. I was kind of like, do I just put it on the mesh struct? I mean, yeah, sure. Let's put it in here. Avec 3 set Actually, no, we have the whole centroid. The whole has triangles, right? The whole has faces. That's what we have it on. Okay, well in that case, we'll just put this on the hole itself. So we want to add A to B. We want to add that to C. And that to D. And then we want to scale center by 0.25f. And then the whole centroid equals center. And we will use this later to determine normals. Okay. Okay, so here's the hard part. For each point, we need to have a visible vector. How do I get my points? My points are on vertices. Hopefully our vertices aren't a different type. I don't really remember if they're... No, yeah, I do push them as vec3. Okay. Okay, we're just going to go through all of the vertices. That's the simple outer loop, outer structure. Okay. We're going to have a vector for visible faces. We're going to init this vector to 0 with a type size of triangle, since these will be triangles. Only at the end will we free visible faces buffer. Only at the end. While going, we will touch the count, right? So at the end, what we will do is we'll go visible faces.count equals 0, and we'll restart. During this, for each vertex, we want to see which faces are visible, meaning are facing away from us, or facing towards us. We'll see there in a sec. So we need to go through all of the faces first of all. We're going to call it F for face. And I think what we want to do is we want to prefetch the tricky part about this is that our No, it shouldn't. It shouldn't actually. Yeah. So our faces is going to be the mesh hole dot faces, and we will cast it as triangle. So we want to be going to the faces dot count. The hole dot faces dot count, and that count will be changing during the loop on the end. Okay. Push father node first, then don't care about sorting. Yeah, that's not a BBH though. But I mean, so what I'd recommend, I can send you an implementation that deals with it for you. But it's pretty important, right? Because when you're building something with a lot of things inside of it, you always want to be, if you have to check every bounding box against every bounding box every time you recurse down, that's like way long. The sorting algorithm isn't that crazy. I have it right here. It's just you. So this is literally, it's just a few lines here. So you have I, which is your parent first, and then you have J, which is the end, right? So you have this chunk that goes from I to J, and then you just have a while loop here that if the centroid for the current hole that you're checking is less than the split position, then you don't move it and you just increase I. And then if it's the other case and it's in the other side, then you need to swap them, right? So that it goes to the other end. And then J decreases. That's just the algorithm. That's just it. It's not that crazy, but it is very worth it, I think, because it limits the conversions a lot. It limits the comparisons a lot. Yeah, it's worth it to check. Yeah, to check out. But yeah, that's the good thing about a BVH, is that it's not really just split in the center, because you end up getting, like, here you end up getting a different amount of leaves in different places based on how many things are there, right? You get what I mean? But that's how it knows where to check, right? But maybe you get there anyway if you just always split exactly in the middle, but I'm not sure. Okay. If d is greater than 0.001f, then you want to add it to the visible faces. Okay, so in this case we will vector expand by 1. Does this actually check? Yeah, it does. It does. It doesn't actually do this. So if I just do do I want this to be triangles? It's kind of expensive. I could just have indices, actually, right? Huh. Let's just copy it, because I don't want to worry too much about just the thing. First split, second split, root A and root B are getting new siblings. First leaf and second leaf. What do you mean by root A and root B, though? Okay. So we're now getting our visible faces. For each visible face, count edges that are shared between visible faces. So we will get our visible faces. We want to check edges that are shared between them. So we're just going to nested loop. Root is just the bounds. I see. You don't use left and right. Yeah, you don't have to use left and right. If f equals vf, continue. While it would be nice to trace up the tree, do you really need it? What do you mean trace up? What does trace up mean? Okay. Connect P to each horizon edge. If count equals 1, this is a horizon edge. Connect P to each horizon edge. Count edges that are shared between visible faces. Okay. Okay, what's the most efficient way to do this? We could simply create a list of unique edges and then count which triangles have that edge on them. We could also go, I was going to nested loop them right here and test against them. But then I'd be counting twice. I would be counting twice. So I can't really do that. Unfortunately, I think the easiest way is to loop twice. Create a list of edges, and then create a list of edges, and then check per edge how many times they appear. I think that's the way to go. Tracing down is tracing down the left and right child, tracing up the parent. Yeah, I'm not sure why that would be useful necessarily. Fuck. Nah, yeah. Yeah, we need unique edges. Okay, let's make a new type. I might have a use. Yeah, it's useful to keep the parent, pointers or indices there. For sure. We got A and B. Yeah. We'll just keep the counts separately, because we can't do this. Where's horizon edges declared? Oh. I just misspelled it. I was freaking out. Snipe out the parent index? Yeah, that's fine. I mean, I just naturally store the parent index because, you know, it's kind of free to do so. You could also do the fancy thing where you linearize the tree and then store the parent's right child inside of the left child so that you never have to recurse at all, which is kind of cool, but that's hard. Okay. So now we have our horizon edges. Okay. We want to check we also want to reset at the end horizon edges count. Okay. So we want to go through all of our current horizon edges per edge on this. Wait a second. No. Fuck. We're gonna make a function called check horizon edges. It's gonna take in a triangle. It's gonna take in the edges. No, it actually has to take in the whole vector. And I think that's actually it. The reason why I have to do this is because we actually need to do this many times. Okay. So we loop through the edges. This is actually, so the fucked up part about this is that we need to do this 3 times, but due to the unique position that I'm in, actually no, we can't do it like this. Holy fucking shit, we're coding right now. Okay, hold on. As we push on, we can also, as we push on, we can also, we can also have counts for each edge that we're updating. Instead of, I'm just trying to figure out in my mind if that is the exact same thing as if we had, if we, trying to figure out if that's the exact same thing as if we counted afterwards. Counting one time is obviously better than counting twice. So if we add on every time we find a unique edge, and every time we find one equal, we add on. I think we can just do that. I think we can have just a counts Okay, there we go. And then the min size thingy, I can obviously eat that off. I don't need to snap the size. Yeah, maybe. I'm not sure exactly what the application is. Am I supposed to start at 0 for this? Let me look this up. Okay, that's not telling me fucking anything. I don't know if it's supposed to be 1 or 2 that we're supposed to start at. But all I know is that if count equals 1, this is a horizon edge. But I don't know if we're supposed to start at 1 or start at 2. And Google isn't telling me fucking shit, so. Well, this doesn't need to be visual, so I don't need it. Alright. Okay. So now all we need to do is check horizon edges. And now we just need one for horizon counts. Okay. Okay. So now we need to go through all of the horizon edges. And it says to discard them if the count is greater than or equal to 2. I don't know about if there is 0, but I guess that the count is supposed to start at 1. That's what I'm gonna guess. Let's get the counts by castVec. Horizon counts. Cast it to int. So we have our counts, and if counts h greater than or equal to 2, then we discard it. What's the nice way of doing this? Okay, so let's just do less than 2. Then we connect P to horizon edges. But before that, what we can do is delete visible faces from master list. So our list of faces is this. Which we should probably move into here, just so that we get the newest one every time. Newest pointer, I mean. Because we're going to be doing stuff. Well, actually, it doesn't matter because... Yeah, the question is, how are we going to delete faces from the master list? We could swap them. Swap the pointers. It would be really convenient if I had double pointers for this, for the vertices, because, or for the faces. When I set up initial hole points, where do I get my faces from actually? Did I do this when I decompose? Oh no, I guess I start when I do this. Oh yeah, I do. I put them on the list. So we only start with 4 faces. Yeah, I don't know. I think I'm overthinking it. I mean, the nasty way would be to, like, obviously just straight up copy the triangles, but I don't want to do that. The way to get around that is to just use indices, I suppose. I'm about to get unhinged here in a second. um, we're just going to set it up with the initial indices. Man, it would be nice to make a make a macro that could do all of this. That could loop through. I don't want to make a macro that does that right now. That would be such a fucking pain in the ass. Oh my god, that would be awful. We're not gonna do that. We're just gonna hard code. Well, we're not gonna hard code it, but we're not gonna shrink. We're not gonna shrink. Just gonna do that. Okay, just gonna do that. I'm gonna become unhinged in a second. Okay, so we also, instead of just, okay, so we also need visible faces indices. Okay. Okay, every time we add to visible faces, we also need to take general. Oh, you're still fighting Qtile. Why am I? You are now number one. You are now number one. I'll check general in a second. Sorry, I'm kind of like locked the fuck in right now. This code is like what? This code is fucking crazy. Whoa, 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 whoa. Jesus. Wow. That's that's quite a bit of language you have there. Jeez. That's crazy. Okay. 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 So we all we need to do is remove int from vec uh whole indices. We're just going to remove uh she larps everything. What is was she responding to you saying that Helix is good, or did you just like say, just out of the blue, think it would be easier to store an index array on the leaf? I originally designed the struct in mind for ray tracing, but this is a CPU, so it doesn't matter. I see. What does zonj mean? I was just saying, like, when you're like, I'm sloshed, I'm lost in the sauce. Like, zonch sounds like one of those things. I'm totally zonched right now. You know? I'm zonked out of my mind, bro. You know? I don't know, man. I'm just fucking lost in the sauce right now. Okay, so instead of whole faces count, you posted context? Okay. As long as you were being friendly, that's all good. Maybe with the context is better. I didn't know that you were that passionate about a Helix after just being one day into it. That's intense. That's crazy. Helix and Vim are the same. Yeah, that's a fucking stupid take, man. That is dumb. That is ill. Sorry. That's a stupid take. Anyway, we're not going to go through the whole faces count. We're going to go through the uh, whole indices, but not the whole indices. We need... fucking Christ. And then instead of faces F, we'll go indices F. Don't like her LARPing. Okay. Believe it or not, I think we're almost done. Okay. So if the count is less than 2, that means we now have deleted the visible faces from the master list. Now we just need to connect P to each horizon edge and emit new faces to the master list. Did you hear what I said? Okay, so okay. So basically what we're doing is we have indices that when we remove from the master list, we just remove from the index and then shift over, because I didn't want to deal with copying triangles, right? Because that's just slow. So it's like, okay, let's do it the fancy way. Now we have a fucking problem, okay? Because now we need to add faces to that list. Okay, so that's a problem. That is a real problem. because now we're going to have to do a nested loop to figure out what index isn't in use. You hate to see it. You hate to see it. No, we're not gonna do that. We're not gonna do that. Instead, what we're going to do is we will just add to the end of the master list and add the index, and at the end we will clean up the master list. That's what we'll do. That's what we'll fucking do. Okay, let's do this. So if our count is less than 2, we will connect P to each horizon edge and emit new faces to the master list. Okay. So connect P to the edge. That means that our points will be P and then the 2 edge points. Okay? We all understand that? Okay. Okay, so how do we want to approach this problem? Okay, so we can make a function that just takes in the faces and the indices and then updates them both. That's all right, but we can be a bit more modular with it. Okay? Taking the edge, taking the point, taking the faces, and taking the... Okay. That's what we'll do. We'll just put it in a function. When in doubt, just put it in a fucking function. Okay? Add horizon face to faces. Okay. So here we're going to put in, we need a couple of things here. We're going to take in a vec3p. We're going to take in an edge e. It's an edge, believe it or not. We're going to take in a vector for the whole faces and a vector for the whole indices. Okay, lock the fuck in. Okay. Oh, it's gonna rain. It's beautiful. Okay. Vec3a equals p. We're just gonna do a little bit of this because I need it extra explicit. I need extra explicit on my burger today. Do you understand me? Okay, we need to make sure we have the center. We did get the center at the beginning. So let's just take in a vec3 center just to make sure we're doing this shit correctly. Okay. Okay. We're going to do this exact same thing here. So this is going to be a face pointer f equals the vector expand of whole faces by 1 because we're adding a new face. Use of undeclared identifier f. Don't worry about it. Stop talking to me about it. Should I remove the job variable and tell a bottom from -1 on the A and B index and just count down from top at index 0? Okay, let's read it again. Remove the job variable and tell a bottom from -1 on the A and B index and just count down from the top at index 0. Yeah, sure. Yeah, you need to know when you have a leaf, right? And for me, I just have null, right? because I use pointers instead of indices. So at the bottom, I just have a leaf with null as left child and null as right child. And that's how I know. That's how you know. Banger song. Okay. Lock the fuck in. So F, use of undeclared identifier F. You gotta work with me. You gotta work with me. You absolutely have to work with me. What do you mean? Can we chill out, bro? What is the deal? What is your problem, dude? Oh, I don't. That's not called a face. Right. But it's a triangle. Well, in this top is always going to be 0. And, well, you'll know if your bottom if both your children is -1 and Zeus should struck you. Yes. Yes. For me personally, the top is always, the top, So, I don't think you need to know what the top is because the top just doesn't have a parent pointer. But, that's at least how I do it. Also, I typically start at the top. The top is index 0. Yeah. Well put. Okay. So we do this, and then we compute triangle normal with this. Okay. Now we do the same test with the vec3 dot, but we are doing it this time with the center against the F normal. Okay, excellent. Then we need to swap 2 vertices if that's bad. But that's never going to happen, right? The word job is red. You just fired them from their jobs. That's mean. Okay. So we vector expanded. We put that guy at the end. And now all we have to do is also go we need to also vector expand the whole indices by 1. And I will become no, not store 64 HR release. Whole faces dot count -1. By golly, I think we done it. By golly, I think we done it. By golly, I think we have done it. I know I'm quiet, but I'm like this close. I'm this close to like actually like getting on top of my chair and like scaling the fucking wall. Stop. What are you? Do you hear that? The fuck is that? Okay, so P is our original point. P is our original point. Holy shit, that was a long time ago. We do have on the mesh the center, right? Hold dot centroid. Yeah, absolutely. Just send it. And then we need the faces. I think that's actually whole faces. And then after this, it's the whole indices, which are just simply called whole indices. Why is this not correct? Edge E. What? It's an edge. Oh, it's an edge pointer. Okay. Wait. Oh my god, I think it's over. Oh my god, I think it's over. Okay, I have no clue if any of it works, but at least I fucking did it, okay? Bro, that was like, oh my god. This was painful. This was painful. Oh my god. Let's make sure that we are allocating 5 and we're freeing 5. That's fine. Okay, the tricky thing is that at the end we have to take our whole indices and now basically rebuild the array. What I can do, like very simply, I don't know if this is, this might actually break things, but what I immediately just thought to mind is that our whole indices is always has, oh, well, it always will be bigger than our wholes. So I'm just thinking maybe we can just skip over everything. Redefinite. Hi. There's no way that we end up with more, right? How about this? If whole indices dot count is greater than our mesh whole dot faces dot capacity, then we'll just vector expand mesh whole dot faces dot faces by whole indices dot count. Okay, very simple. Zeus, is it really that loud? It's not that loud for me. We won't do that. We'll just do this obviously once, and then for now, like what we have to do now is that now that we know we have enough space, we just need to get our faces, which we will cast here. We want to do that after we vector expand, of course. And we just want to go faces I equals faces hi I. That's it. Oh, you want to do this. Indirection requires pointer operand. Yo, chill. Oh, I guess that is fine. Oh yeah, we don't have to. Okay. And then our mesh whole dot faces dot count equals the whole indices. No C style cast. Treating the compiler. Okay, and now all we need to do is call this function called incremental whole and pray that I'm not a complete fucking idiot. Which, you know, no guarantees. No guarantees. So you would absolutely love it if we could print out our triangles. That would be neat. That would be like super fucking swell. So let's try and do that before we get all ahead of ourselves. I'm fucking unhinged right now. I need to calm down. Okay. We're going to go into whole dot faces dot faces dot count. Stop calling myself an idiot or stupid. Thanks, I'm flattered, but you're not going to be singing that tune in 10 seconds when I crash my computer. Because that's actually what's going to happen. Like, we haven't compiled in, like, 3 hours, man. Like, this is not looking good. Okay. I'm flattered, though. I'm flattered. Okay, so we get the tries, and all we want to do, listen, I'm just so happy. I'm happy. All we're gonna do is create a new vector. Actually, yeah, let's just create a new vector, okay? Called vector triangles. Okay, we are going to init vector triangles to 0. The type size of set. What was I doing here with these? Huh? Vec3? Okay, we're just doing a Vec3. No normals. Yo, what's up, Isabel? Computer indeed. Okay. Okay. So we just get a Vec3 pointer. I'm cracked out of my mind today. This is not good. Okay. we're doing fucking incremental hole algorithm today. It's not pretty. It is not pretty. It is really not. Um um I don't care. Like right now, we're just going to do this one by one by one, and we're just gonna like. I'm not actually gonna worry about it this way. You're making a canvas hole from mesh triangles. Yes, that's what we're doing. This is just like debug, trying to get something on the screen. But basically, I have like this decomposition thing that makes it into convex holes, and then we have this we're connecting our horizon edges to the visible faces and all that. You know, I'm doing it the fancy way now. Computers weren't a profession, but a machine that does math. These computers are a profession? What? That's crazy. Okay. Yeah, now we just free the triangles dot buffer. Yeah, just free the buffer, but before that you're just gonna upload it like so, and then we're just gonna draw. Okay, moment of truth. Okay, we have a count of the triangles are a vec3, right? Okay, I'm not stupid. Okay, we're fine. Okay, we're gonna crash the computer. Is there a reason I put spaces? I just like how it looks. Hey, what's up, Lily? I just prefer the look of it. Okay, so we have. Okay, I wasn't actually expecting this because we did change this name. So what I'm gonna do here, because this function actually isn't important anymore because we aren't doing like the raw 2D decomposition, I'm just gonna straight up comment it out and we just aren't gonna worry about it. Oh, you guys are fighting for number 1 again? Find simplex point. Oh yeah, I just didn't finish writing that function. What? Oh, undefined reference to compute mesh holes. Oh, it's mad because of this. And oh, mesh BVH. Okay, yeah, that's a different function. Okay. Thunder, it is thunder. Okay, so we crashed, which is exactly what I was hoping for, because if this worked, then I was like in some fucking, David Lynch dream, So I'm glad that it didn't work, in fact, Okay, so the first thing I want to check out, absolute first thing we need to check out, is I want to make sure that it isn't just on the render side that, okay, so it is on the render side that we are, okay, so this is good, because if it's something that I did here, M hole face is triangle. Okay, so where did I make an oopsie? Oh, that's where I made the oopsie. That's indeed where I made the oopsie. Okay, so the white for the uninitiated is the hole, and the white is obviously not on the outside of the face. It's, in fact, I think it's so this is what I'm going to assume. I'm going to assume that what we're seeing there is actually just the initial tetrahedron or whatever. So that's what I'm going to assume. So that blows. Yeah, that should be correct. Yeah, I didn't do this wrong. I didn't. It's supposed to be jail triangles for sure. Okay, so we need to actually just like print out the points, because I actually just need to know. Actually, the points probably aren't going to tell me much. How the hell do I debug something like this? Okay, here's something that I want to check. I want to check if I that number that we weren't sure about before, like what if I start this actually at 0 and see if that does anything? Because I was wondering if that was supposed to be at 0 or not. Okay, it didn't really fix anything. Okay. Honestly, like literally anything could be wrong because I didn't really verify anything when I was writing the code for it. So now we have to figure out where I fucked up. We can start from the beginning, right? I want to check. We didn't get any errors. So I want to check here what my original points are. A, B, C, and D. Okay, are we done? Yo, I don't want to have to do this. This fucking sucks. I'm just gonna try to speed it up, I guess. Dustman? Starman. I promised myself that I would get this done today. I have a worried, actually, that it is our normals that are somehow incorrect. So let's see what our initial points are. Yeah, this is not going to fucking tell me anything. The D point is scary. That doesn't seem like a real point. Unless it really is at 1, -1, 1. That doesn't sound like a real point. Yeah, that's what I was worried about here with this distance formula. I don't know if this is correct. Because it feels weird that you're dotting to get distance, but maybe. I don't want to have to printf the fucking point. What is it, dustmite? It's a nasty little bugger. That's what it is. I want to see the dist, obviously. Okay, let's see what we got. So we get who the fuck is that? Is this a real point? Okay, we're gonna actually check the mesh.object file, and I'm going to actually check if this is a point on the fucking file, because it is. What? You're lying. Okay, so that is a real point. Never mind. Okay. All right. Here's something. We might have to. I may have done the recompute normal thing incorrectly. So the normals may just be fucked. I think that's like the most likely scenario. We do get recomputing. We do recompute once. Now the question is, the way to check this is to do this twice. So I want to see if we need to recompute again, because then I'll just write a function that does that, and then we'll be fine. But I need to know if I need to recompute twice. I probably do. I was just fucking lazy to make a function that does it, but I was hoping that we wouldn't have to do it, because I thought that we could just switch 2 points and we'd be fine. For a second thought I had, oh no, that would have been some really forbidden tech. No, we don't recompute after. Okay, that is really good to hear. I thought we were fucking toast. Okay, we're fine unless I typed it in wrong. No, I think we're toast. We're not toast. We're absolutely, we did it correctly, I think. I guess we could also verify against the centroid just in case. Yeah, the problem is, like, I wonder if this decomposed mesh thing is fucked. So if that's the case, then we have a problem. We go into mesh vertices, and we're sure that we take from mesh vertices, right? We do. Absolutely. Absolutely, yeah. We go into points, yeah. Yeah, we take from mesh vertices, it's correct. Stop saying words now. Dude, you know, it's like a part of my. I have to say words, or else it's like. Would you rather me just not talk? That would be bad. Okay, let's see the logic for check horizon edges, because this is most likely, you know, a place where it could go wrong. Is there something else that I can use to debug that would be left over after we do have, oh, we do use faces. That's what we use. We could feed points into GL points just to see if we have all of them. That's what I'm going to do. I want to make sure that our input is correct, because if our input isn't correct, then we're just, you know, we're just really in a pickle, you know. All right. Is it hold.points? It isn't hold.points. It's just straight up vertices. If you see me, that's the second time you said that about the Ubuntu. Did I just say Ubuntu like that? What is the fuck is wrong with me? Ubuntu. Oh wait, this is just one. Oh my gosh. I'm so stupid. It's that simple. It's that simple. It's that simple. Okay. We don't want to be going into. Oh no, it is. Yeah. It just goes into. Wait, no. We're not expanding we're expanding triangles. Yeah, I'm sorry. It's getting to that point where it's like, you know. It's getting to that point. All right, we're going to go points. Oh my gosh. Okay. Well. Point size 10. It's quite tiny points. Okay, there we go. These are the points that I want to see. Okay, so this is the problem. So herein lies the problem, that we're missing a point. Sir, we are missing a point. So all the other points are lovely, but we are missing one point. It's a critical point. It's very critical. So how are we missing it? Okay, let's make sure that we didn't mess anything up here. Vertices. Looks good to me, boss. The thing I made private? Stupid IDE? Right, Helix would never. Okay, so we're missing... Fuck. How are we missing a point? Well, at least we know where there is a problem, and we can hopefully find it. Let's get rid of this unique point check and see if that's what's causing it. That is what's causing it. Okay. If Vec3 equal A and B unique equal false. The fuck code did I write here? What? First of all, why is this not 3? Oh, no. What the fuck is wrong with me? I'm supposed to... No. No. Get the fuck out of here. What was I writing? No, you're not supposed to nested loop through... No, you're supposed to loop through... You fucking moron. You're supposed to loop through the actual vertices already. Fuck, man. You're supposed to loop through you fucking idiot. You silly goose. Okay. Sorry, I hit the mic too. If it's equal... Okay, so the reason why this is weird, right, is because I was checking the list of triangles if there was a duplicate before I added it to the array, instead of checking the list that we've already added to the array. So basically, I was just not adding indices that are duplicated, regardless if it was the first time that I was adding them. So a bit of me being a moron, but that's fine. It's like, you know, it's one of these things where I'm like, you know, a moron, and it's endearing and it's cool. Love it. Okay. So now we have that point. Fantastic. Okay, now is the algorithm gonna work? Probably not, but you gotta give it a shot. I wish I made this easier for us to go back and do here. Wait, did I just... Okay, I totally tore up... Oh, no, I didn't. It didn't. It's right here. It is right here. Okay. Okay, so let's give this a shot again. I doubt that we're going to get it correct. Dude, it's almost there. It is inside, though. That is inside. It's close, but it's cutting edges. It's cutting edges. Fuck. We're close. We're closer than it was before. It's close. We're just cutting edges somewhere. Fuck. Okay, so when we set the whole centroid, is this correct? Maybe. Apparently that's correct. Apparently. Wait, hold on a second. I didn't return true there. Ah, shit. Ah, shit. Alright, let's test something here. Let's make sure that we aren't just like covering it with the other thing. I would highly doubt it, but yeah, we aren't. Fuck. Okay, so that was just the initial tetrahedron that we were seeing. I didn't actually return out of the main function before so we weren't even cooking yet. We didn't even enter the main loop. We just did this. So we were just returning out because we didn't return true or false. So you hate to see it, you really do. At least we didn't crash, but I do indeed get the feeling, though, that we're close still. The interesting thing is that I bet that our faces count is 0 at the end, which is obviously not supposed to be 0, but that's based on us not rendering anything. That just makes sense to me. That's a ZU. Faces count 8. Oh, we do have faces count 8. That's not a lot of faces, but well, may I see the faces, perhaps? May I see the faces, perhaps? Yes. Let's try and see what the faces are. I wish I could see it easier. I'm not gonna not gonna lie. Like, this is you know, I've got a brilliant idea. I'm so brilliant. Oh my gosh, look at this. Helix. Look at that. This is what we love Helix for. So that when you write bad code, you can at least debug it. Nice. Except for the fact that, you know, you could just use a debugger if you didn't use Helix. But we just ignore that. All right, let's have a gander. Okay. I'm not gonna lie to you, bro. I'm seeing a lot of bad stuff happening. So we have 8 faces, and every 3 faces is identical. Oh, and also, they're all degenerate. Okay. Okay. You hate to see it. Okay, here's something. It may be, you know, when I was saying that I was taking this shortcut at the end, it may be this that's the issue. It may be this right here that's the issue. I'm just gonna make a thing called void print triangle, and it's just gonna take in a triangle naturally. Oh, that's a lot of leaves. That is a lot of leaves. I'm telling you though, if you go I think the whatchamacallit, the sorting way might give less leaves. So it may not be that bad. Should I benchmark it? Yeah. I don't know what you would be benchmarking it with, but okay, we're gonna print out some triangles. Okay. So before we ever get into there, they are incorrect. And I bet we can also check the index is going to be all the same. 4, 6, 7, 8, 9, 10, 11, 12. Okay, so we have duplicate triangles in here, though. Oh, sorry. How do we end up with duplicate triangles in here? How do we have duplicate triangles in here? Oh wait, maybe... Oh, but our whole faces only start at 3. Huh. Maybe when we add horizon face, then we should print the triangle here. Let's do that. Whenever we add a face, let's print it. I have a feeling we'll find something interesting when we look at it. We probably are adding correct triangles. No. No, we aren't. Okay, well that's something. Fuck. 16:4. 16 steps, 4 minutes. 4 minimum try. Still generate? Yeah, min try 1 is probably pretty crazy, huh? Oh my gosh. Oh my gosh. Oh my gosh. Oh my gosh. I put A instead of B. Faces count 0. Fuck. Well, that's our algorithm being wrong then now. Let's do the same thing. Let's do the double check with the... Let's do the double check with the normal just to make sure that it isn't the normal that's being bad. I just want to see bad here. No. No, the normal is fine. You're 30 gigabytes. Jesus. That's crazy. That is crazy. I'm definitely slotting it in at count -1. So there's no way that that's incorrect. And then we can verify it by printing the triangle that's at that index. We just have to verify that these are the same. Oh, 128 gigabytes, that's a massive amount of RAM. Okay, so they are the same. They are the same. So that is correct. But faces count 0. Maybe I need to change this number back. That we changed it, but maybe... Okay. We have something this time. Seven faces. Let's see if we loosen up the restrictions, do we get the full hole? No. It's mangled. So that's good. I mean, at least, you know, at least it's showing us that it's not correct. Like, that's obviously mangled. Because that's supposed to be 2 for sure. It said actually 1, but that just sounds ridiculous. Now we get faces count 0. Four computed fast, I think 2. Storing all the indices instead of count and offset. Oh yeah, what are you doing in each internal node? You have all of the indices that are inside? Like in arrays? Like in individual arrays? That's a lot, yeah. That is a lot. No, yeah, that's incredible. That's incredible. Yeah, do not. You have to have one array that. Yeah, you can't have arrays per node. No. Yeah. Yeah, like I said, you can have one array with like BBH indices where each of them index into. I do 4 and it uses fuck all. Yeah, I mean, definitely want the indices for sure. It'll definitely be good. One and two are dense. Yeah, I think it's just like an incredible efficiency thing to have it. That's a lot of memory. Fuck. Oh, wait a second. Oh no, we set the count to 0. We do set the count to 0. So every time we get this, it should be at 0. Yeah, I feel like that's like a lot of memory even so. I think you should, I don't know, even if you don't want to like do the sorted list thing, you could at least like just do leaves, right? You could just have one massive vector that each leaf indexes into, and whenever you get a leaf, you just store the indices for the leaves, and just push them onto the vector, because that's just an incredible amount of memory to have each internal node, because at the end of the day you're just going to be using the leaves anyway. um, yeah, yeah. The index that I use here is visible indices F. The visible indices, I put them to F and not indices F. No, I don't think that it's supposed to be indices F. No, it's not. It's not supposed to be indices F. It's definitely not. It's supposed to be F because F is the thing that is doing our indices. Yeah. Yeah, I think like that's the way that I have mine set up at the end of the day is I I only use the sorting for building the tree. The rest that I use for for the leaves, I have just a massive vector that they push onto and that they index into. The sorted list is really only for sorting the tree because I have it so that uh, different holes can be duplicated based on the bounding boxes. So some holes belong to both, and so for that reason, I can't use the sorted list anyway at the leaves. So the leaves have their own cortisol spike. I don't know. Probably doing something wrong. The only acceleration for building the tree is I take the affected indices the father leaf hit, only scan those. Yeah, that's basically what the sorted list is doing, yeah. That's basically what it is. It just doesn't search the whole, like, so let's say you have a bounding box, right? You have to check everything to check what's inside the bounding box, right? And so every time you go into a child, you just pass the child what was inside of its bounding box. Does that make sense? You don't ever check against everything else. Like, so that's what the sorted list is you have a bounding box, you split it into left and right, and then you have that. Okay, yeah, that's pretty much what it is. Does vector expand? Vector expand checks, right? It checks for count. It uses count. So if I set count to 0 at the beginning, then it should be fine. This guy's dustmite. That makes sense, yeah. And then sorting the array that the leads are in. Thought I'd show you that bit in the Discord. Yeah, I don't really remember. But my bad. I'm worried we have multiple indices. So what I'm going to check is, I'm just literally going to check indices F. I want to make sure that we don't have something funny here. I just want to see 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. And then we stop. Unless our... Why would we stop? Unless our actual vertex count is wrong. There's no way. That would make 0 fucking sense. And indices is the affected indices. It cuts down every step. Yeah, but do you have an array with like a start and an end? I guess that's what I was. That's what I'm referring to. 12. 12. 12. So we're supposed to. So our whole indices dot count goes down to nothing. I haven't added that when building the thing. I just put. Yeah. I mean, that's just a lot of memory. Yeah, it's very. It's just like very small amounts of code to do the. Yeah. Well, that's the thing is that the whole once you recurse all the way down, right? Like now you have all that memory. Yeah. But it's very I can show you the code. It's very simple to get that list, because all you're doing is you're just splitting it into the left, what's going into the left and what's going into the right, and that array just like never gets touched. How does the whole indices dot count get? Oh, the whole indices dot count. Yeah, so it just deletes everything on the second one. Maybe it's only. If count is greater than or equal to 2. We can check that, right? If the horizon counts. Yeah, I think. Fuck. Yeah, I don't think that's it. God damn it. Choose the offsets instead of indices, and pass the pointer to the indices so that they don't. Yeah, yeah, that's. I want to see what this is. I'm just going to assume that this is everything. This is going to be 0 through 6. Yeah, 0, 1, 2, 3, 4, 5, 6. So it deletes literally everything. So then this has to be wrong. Because I'm just going to assume that we push everything is visible. Yeah, we push everything is visible. Let's print the triangle. See if they're all the same. They are different. These two are the same though. If instead of indices, if I go just by F, fuck. Visible faces indices goes to F. No way of visualizing this. Can't you just put a wireframe as the AABBs? At least that's what I did. Restore how deep the leaf is. I see. I need to see where my other printouts are. I do print out the initial points. Do I print out the first triangles though? I think I should print out the... the triangles every time, just to see what we have, regardless if they get in or not. Okay, so this is the thing that I don't understand. Why? I gotta get rid of all these printouts. I'm fucking losing my mind, but why do we start out with nothing? We have to leave one at the end. See, that's confusing. That's confusing. Why do we should start out with 4, and yet we start out with this many. Why do we start out with that many? Whole indices that count at the beginning is 4. So why do we print out this many faces? Unless I have a printout that I don't remember putting there. Which I might, honestly. I have this. That's why. Okay, there we go. Yeah, we're adding duplicate faces. The only real face we add is the one at the end. The rest are duplicate faces. Like this. See, this is a duplicate face, this is a duplicate face. So how are we adding duplicate faces? So we have 4, and then we add 3 more, and we add a duplicate face, and then a real face. I'm thinking that maybe we have to skip our current vertices. I think we have to skip the first 4 vertices and not deal with them again. That's what I'm realizing now. I want to see what P is actually. Oh, it's raining. I want to see if P is a point that we've already processed, which it might be with how little points we have on the thing. That may be why we collapse. Yep, P is a point we have already processed. P is our A. Well, what's an easy way to do this? We could set up an index array for it. You know what? I'm just gonna set indices for all of where the duplicates are, so that we can just switch them and we don't have to worry about anything. So I'm just gonna check that. So the inviting cubes, you can see it's working good. Points. I'll do this into a better thing later. I just want to get this working. The thing is, I don't actually know what the first... I'm gonna delete this code, but whatever. This is disgusting. My cube debug render needs to become static. Oh, interesting. Yeah, I mean, maybe for a big scene, that would probably be true, yeah. Okay. So now we start off with a definitely unique point. We start with 4 and we end with 0. So, okay. This is definitely a unique point, right? Yeah, it is. Yeah, I mean, I don't know. The thing is, like, if I get rid of this, right, and we just look at the tetrahedron, it looks right. Oh my fucking god. What? Shut up. This looks right. Oh, now it's because it. Whatever, like, dude. Okay, now it isn't fucking working. What is the problem? See, this is a correct tetrahedron, right? So this looks correct. This part looks correct. For whatever reason, this part is somehow fucking us up. Even though that makes no sense. Unless this DC might get too many hits. God fucking damn it. I don't want to have to... This is disgusting, man. Just fucking get me out of this. Okay, there we go. Well, that helped us actually, you know, roundabout find a crucial bug actually, so happy about that. I don't know why we weren't seg faulting before, but whatever. Still get the same thing though. Yeah, you know, I can't help but feel like the like the normals might be fucked for the faces. I wish I could render the normals. I could. Like if I did this and then I made this size of vec 3 times 2. Main vertex. And then now we have normals. Basically, most of tonight was cleaning up the clutter. Yeah. So how did the benchmark go? Okay, so now hopefully that works. Doesn't. Main vertex, pause and normal. And why is it not drawing? Wait a second. Oh no, yeah. Yeah, I think to view it we have to get rid of everything. Just to see the tetrahedron. I just want to see if the initial normals are correct. So I have no clue. Like this looks correct, right? RGB is upwards, right? That looks correct. Because blue would be upwards. not downwards. Well, actually, we can unnormalize them. We can unnormalize the normals. So that we can see how they're like originally. Is that one supposed to be that dark? Maybe. Well, that's definitely not black. You're seeing it? Nice. The SDF and voxelizer stuff were embedded in other classes. I see. Well, that's nice. Glad you got it working. How painful is the time it takes to do it? Alright, I'm going to, I think, take a break for like probably 10 minutes. I want to get I kind of want to get another coffee, but it's kind of late for another coffee, but I want to figure this out. So, I mean, the normals just came back normal to me. Like, they look correct. So, I don't know. We aren't... Hide 0, 1, 2, 3, and then we have a list of 0. Oh, yeah, we remove. Oh, wait, we didn't keep this. What I'm interested to see is... we have visible indices versus the horizon edge count. The really confusing thing is that I have visible faces indices and visible indices. Remove int from vec. I pass in whole indices and visible indices f. Oh, but visible indices is visible faces indices, I see. Oh, it's pretty much instant. That's good. Yeah, I might have to make some coffee. So how many new faces do we create? We create no new faces. Well, that's what I was expecting. The check horizon edges. Yeah. Yeah, F doesn't actually correspond to the visible faces one. Yeah. Yeah, I think I'm gonna make some coffee. I'm kind of honestly lost because the thing is, all of my code kind of works. Like, I make the tetrahedron, I think it's correct. It follows the shape. It's the normals are correct, and they get computed correctly. It's just that we delete all of the faces immediately instead of creating new faces. So yeah, on the first iteration we don't create any faces and we delete all of the faces. So that's the problem. Don't know how to get around it, but I have to read through the code. So I'm going to take a tiny break and then I'll be right back. Alright, I'm back. My coffee is still being made. But that's quite refreshing. I still don't know what's going on. I was thinking maybe I don't absolute Dust Titty. Oh, that's a new one. You're back. What's up? So if visible faces dot count no. Yeah, that's what I thought, because we are deleting stuff. Gave up on X Libre. How were you working on getting it to compile? What's going on? Well, I completed the algorithm, but it's not working. That's what's going on. Hold on a fucking second. Hold on a fucking second. Wait a second. I think I did it. Okay. So you're not supposed to fabs this. Maybe. Maybe you're not supposed to. But we're still off. We're still off. Still is off. How many do we have at the end? Faces count 36. Do you use debugger or printf debugging enough? Sometimes I use GDB. It was nice when I wasn't doing this, doing Helix, to use a debugger. But I've gotten used to it. Like in this case, I don't think a debugger is really gonna, tell me, anything that's going wrong with the algorithm. You know what I mean? This is a me problem, not a. You're really tired? Oh, that sucks. Okay, well that's not correct. Obviously. Why are you tired? My coffee's gonna be ready soon. I'm really fucking excited for that. Man, it sucks that it rained for like 10 minutes. Are you kidding me? I get 10 minutes of rain, that's it? You had a long day? Damn. Well, that sucks. I had a short day personally. wonder if this is really, you need to do this. It's strange because this looks pretty close. I mean, not really, but you know. There's just a lot of shit happening inside of it, which is not what you want. Which is why I think you need to do this. But what is impermanence? Visible faces indices. F. Infinite steps makes it harder to track deepness, yeah. Maybe. NixOS where you mount / on tempfs. Interesting. Oh yeah, that's what you were talking about earlier. Yeah, you did talk about that. Turns out infinite steps makes it harder to track deepness. Yeah, I'd say like the way I did it with the chess engine, with that recursion, is that I simply had one thing that just got passed down as a pointer, and each child just wrote data to it, right? Like what level, every step down would increase level and stuff, I think it might be cooked. It might be fucking cooked. Step count is 0. I force it to 1 in the loop so it keeps going. Oh, why infinite loop though? Why infinite loop? It's just stuck at 1. Oh fuck. Okay. Well, I spilled a little bit. It's not a ridiculous amount. Well, I need to get my coffee and clean that up, so be back in a sec. My coffee isn't fucking finished. Infinite steps is crazy. You're telling me that it never reaches 4? Even if it keeps on cutting down the bounty box? I don't know why this is indented fucking weird. Well, oh shit. You might have to just send that and then fix it. I'm close here. I think that this was definitely the play. Maybe you might even need a bigger thing. Also, my coffee wasn't done. It's taking forever to fucking drip. That like kind of blows, not gonna lie. Kind of blows, not gonna lie. I'm probably like I'm probably doing something very small wrong in like my way of implementing the probably the iteration or something like that. It's also like if even one normal is wrong, then the whole thing gets fucked. So, yeah. What I could do is I could test all of the normals against the centroid and just see if that's, you know, just to verify it. You do center and then just see if it says recomputing. Because that should be the same thing. I can't wait till everybody leaves and then I can go back to my light theme. That's gonna be sick. I forgot to get rid of all the other printouts, which honestly aren't even useful anymore, so yeah, we're getting to the point where there's a lot of shit, to be honest, getting printed out. Really dumb, but if I set a limited size like really high, such as 512, then I take the value and subtract 512 and then jam it into abs, should get the value I'm looking for. I'm not sure. It didn't say recalculating. Take the value and subtract 512. I don't know what you mean. Are you telling me you're just gonna like subtract a big number from 512 and then get a negative number and then see how under you are? Is that the idea? I want to see what the center is, I guess. If it's something ridiculous, then it's like, no shit, nothing works. No shit. If I put the step size 0, it's forced to 1 for every step. If it's 512, it's absurd. Yeah, but isn't that dependent on like the triangles per mesh, basically? It seems pretty reasonable, the center, actually. That actually seems super reasonable. So I was kind of surprised about that. Let's see what the duplicate points are. So that's a duplicate. Hold on a second. This one is fine here. Yeah. Yeah, if you're just testing, yeah. Hey, Lily. 1.2. If that's the printout, then that's really wrong. I just want to signify it to myself. If that's the printout, then that's really wrong. Okay, it is wrong. Okay, good. So we do know something here. This is being checked against all of this. Oh, but I don't actually. Oh, I'm being stupid. I'm being so dumb. I didn't actually do this. So I was just checking against nothing. Nix format? That's cool. I don't know what that is. I need to make sure that this is all the correct points. Yep, all the correct points. So that's working correctly. We are skipping the correct points. It does work. 9, 9, 13, that's an example. I see. Yeah, well that's good that works. Tree format is like one big nix format command that formats your entire directory. Well, that's cool. Yeah, that's one way of going about it. That is one way about going about it. Hold on a second. We're using F to go into... Oh. This is confusing. Because we have a... fuck. Yeah, I don't know. This is super. Let's try this. I wonder if we're fucking up at the end. Here it's just gonna have like every face imaginable. It still is missing a bit. Like it's missing this face here. Happy 4th? 6th? It's still 5th here. Last night was crazy. There was a lot of fireworks. Alright, I'm gonna get my coffee. It should be done now. Should be. Oh, I'm gonna be so happy when this is over. Holy shit. I'm gonna be so happy. But it's not done yet. I kind of want to see. I mean, this is stupid, but like, what if I just like turn it the other way around? I'm kind of worried that like it's actually on the cleanup that the problem is. Okay, yeah, that is completely incorrect. This is obviously incorrect because that's only the interior faces. That's the opposite of what it's supposed to do. I wonder if there's like greater than 0 and not do the epsilon and see if like that has anything to do with it. Interesting. I wonder if all of this needs an epsilon, but I'm not sure. I mean, for the stuff that's a normal, it should actually just be a straight up thing. If all the normals are correct, then like what's the deal? Yeah, this is correct. I was thinking here, like, to make sure that this is doing what it's supposed to, but I plus 1 modulus 3 does loop you around, compares A and C, and that's the only pair that hasn't been done yet, so it's perfectly fine. That is correct. I wonder if after you make one... Should go to... I'm so tired I should go to sleep, but I'm writing list? Nix? What are you writing? We could try breaking out here. I mean, it should technically be equivalent. Yeah, it's equivalent. Hey, Selma, nice to see you. The stream has been in your homepage the entire day. Alright, that's cool. Your config. And what does that look like? You send your configuration to general? I mean, you could do whatever you want. I'm not gonna stop you. Yeah, I'm just checking. I feel like eventually what's gonna happen is I'm just going to look at this and then I'm going to holes is in ship holes. Holes is in collision holes, as in like 3D convex holes, to, you know, to check when you're colliding against. I have coffee on the screen. But you know, I'm working on the algorithm that creates them. Sent it in general. Okay, I'll look at it. So we increase. Yeah, you know what? I'm definitely gonna find something stupid that I wrote, and it's just gonna be like one line here. I know it. Um, I this indices. We expand it and then add it. The interesting thing is, so for example, if we take a look here, so this goes to here, that goes to there, that goes to there, that goes to there. This is from one point. So, yeah. I think I should check also if the point lies within the hole. But I don't know how to do that. You think I should accelerate SDF generation with your... Yeah. Yeah, why not? That's what it was made for, right? How do I know if a point is inside? I have no clue how I know if a point is inside. Alright, good night, Lily. I really wanted to get this finished. I don't think I have it in me. I made a stupid mistake somewhere. And who knows? Like it looks a lot better when I only remove this. But I think you're supposed to remove... Like this looks somewhat better. Maybe it's this and then I don't mangle the end. Like I kind of mangle the end. I could just simply... If I want to be like, you know, super... Just make sure here. What I could do is I could just like straight up do a triangle pointer new holes equals malloc hole indices dot count times triangle, and then just go new holes. And then just swap the pointers. Go old holes equals mesh hole dot faces dot buffer, and then all right, let's try this. No, it's the exact same thing. That actually makes me kind of happy because I was worried that we were somehow fucking that up. But it looks like that was just correct from the beginning. Let's see what our HIs are at the end. There should be no duplicates. There's just a lot. There's a lot extraneous shit. That's why, I don't know. I think we're supposed to do this. At the moment, working on doing the offset instead of the indices. Oh yeah, the offset and then the count, yeah. Yep. I'm gonna assume that if I just get rid of this, then it just yeah, I'm just kind of rage compiling right now. I don't know. Yeah, I might have to not do this right now. I don't know. I'm kind of stuck. I'm kind of lost, to be honest. Hold on a second. Oh, shit. Oh, shit. Oh, never. I guess not. Hold on a second. Do I ever set whole... Do I never set whole... How does this even function in the first place, though? If that's wrong. I never set the count to 4. I guess I set it somewhere. God, whenever I figure out what the fuck is the problem, I'm gonna be so pissed off. Yeah, you're tired? Yeah. Yeah, I'm quite tired too. The BVH is pretty cool. Yeah. Yeah, it's pretty sick. It is pretty sick. Instant debug editor because this can be hell. Yeah, are you doing it like I'm doing it with just, you know, making an AABB on the fly? Yeah, it's kind of bad. I don't know. Yeah, I've just been staring at this for so long. I don't really know. I'm guessing the normals could be wrong. That's what I'm like assuming. Because we never We never recalculate our normals, which I feel like that should be. Oh fuck. Wait, no, I do. I do haul. Okay, well, if I update hull with the centroid, then it should be fine. Never mind, I thought I had it for a sec. Yeah, well, I mean, I don't know. This is. Yeah, I was almost thinking, like, maybe just, like, do this just to see if it changes anything. No, it doesn't change a thing. I thought that it would actually do that. Thought that it would change something. Okay, this changed something. Going BAC. Oh yeah, I fucked this up. This would have to be this. This does change something. This does. This does change something. This does. Fuck. Let me try the center against the first ones. Did that knob said, and obviously it would be less effective at narrowing the search, but more memory efficient. I can see a lot less dense. Yeah, it is way faster. Yeah, for sure. Did we get any? No, it's always the normals. If I turn this around, it will obviously say that yeah, it's bad. Say recomputing. So our normals are correct. Oh, but we aren't using... We weren't doing this. We weren't doing versus... This is the first point. I don't think I did it right. It looks odd. Yeah, 100% is, yeah. Yeah. And points is mesh vertices straight up. Points is mesh vertices straight up. Yeah, I don't know. I'm kind of tired, so I think I'm just gonna give up. I mean, like, I probably will figure it out tomorrow, but yeah, I'm just kind of staring at it and not really getting anywhere. It's kind of bumming me out, to be completely honest. I want to try something. Can I just do this after? Because the thing is, visible indices doesn't actually, because now we added on. Maybe fuck. No, I mean it should theoretically it should visible indices should still go. We're just adding on to whole indices on the end, so uh, this visible indices should still be going to a valid place. It's not like we're pushing inside of the array here. You're going to bed? Yeah. Yeah, I'm probably heading out here in a second. I just really wanted to get this done because I did so much work trying to figure it out and I don't know what I'm missing. Um all right, I mean like I really wanted to get this done, man. I wonder if changing you'll get there. Yeah, I need to like look up what I'm facing right now because this is not. I mean, it obviously it follows the shape, but it's not. It's cutting through the mesh and not deleting the all of the stuff. So yeah, I'm gonna have to look it up. I don't really get it. Like I don't think that this is two. It's not gonna do anything. Yeah. I wonder if it ever hits two. I I. We can check. I need to check this. After this, I think that the collision is like relatively easy. Like this is like the hard part. Which is why I just did Jarvis March tools before, because it was way simpler than this shit. This is like ridiculous. Nice, yeah. That's good. Oh, is that a Jarvis joke? The worst part, so the coolest thing about like fucking everything else in programming is that like if you look it up, you'll get something. When you look up any problem, like if I look up, hey, how do I delete the the other visible faces in, incremental whole algorithm. I'm just not going to get literally anything else. I'm not going to get literally like anything. Like, I've already tried. Like, the amount of scraping I've had to do at the bottom of the barrel to understand this is like ridiculous. Jarvis. Dude, Iron Man sucks. Sorry, Iron Man guys. I mean, Marvel sucks, but I think that Iron Man has a specific amount of suck that's kind of incredible. Yeah, you had to do scraping? Yeah. I literally can't fucking figure anything out for this. Once the horizon edges are identified, the old visible faces can be removed, and new triangular faces are created by connecting the point P to each of the horizon edges. I thought that horizon edges are literally just every edge, but maybe not. Yeah. They are industry standard. Yeah, nobody had sources. Yeah. Yeah, I don't know if this is gonna click for me. I'm not gonna lie. The horizon consists of edges that are shared between one visible facet and one invisible facet. One visible facet and one invisible facet. To every edge along this horizon. Okay, the problem that I see with this is, okay, like, oh my god, this is fucking hard. That has to be the problem then, because we're cutting across the mesh. Right? Like, we're cutting across the mesh. Like, this shit is cutting across. Right? Like, obviously this should go to there and there, but it goes to there instead. I'm scared to ever do convex holes. Yeah, this is pretty fucking cursed. I mean, the algorithm makes sense, right? So we check if a point, can see other faces. And if it can see other faces, then we see if it can find those faces and how they see border on faces that we can't see, right? And then we call that the horizon, and then all we do is we just connect to the horizon. The problem is that, well, I don't know what the problem is. It just doesn't fucking work. Gate kept secrets? Yeah, kinda. I don't know. I think most people just suck. Sorry. Dude, nobody writes about this shit. Like, what else am I supposed to assume? I don't know. or STFs for collisions. I feel like you should give it a shot. You know, give the give this shit a shot. You know what I mean? What is a double whammy? I don't know. As a crude way to two collisions. I don't know. I don't know about that one. I don't know about that one. At that point, you might as well just use like, you know, AABBs. Like, it's important to get like valid collisions because of like, you know, slanted surfaces and stuff like that. Like, you don't want it to be bumpy. That's not. That's important for it not to be bumpy. Fuck. I think my definition of a horizon edge is wrong. I've got a paper from Purdue University. Oh, this is a good paper. Oh man, I didn't see this before. Something that I want to make sure is that this mesh is indeed convex. Because it might not be a legal convex hole. Like, that would be fucked up if this whole time I was just... I'm editing it in Blender right now. If this whole time I was just, you know, fucking with just a barely not convex hole. That was the problem. That shit would piss me off. But I'm starting to think that might actually be the problem. Like, the more I read that paper, I was like, damn, I kind of am doing this right. Alright, I edited it a little bit to be more blocky. We're going to export it again. And we're going to try this again. Okay, never mind. It's fucking cooked. It's fucking cooked. Never mind. Never mind. I thought I was cooking. And then I realized that I was the fool. And I'm not tripping, right? Like we can still do like just draw the regular thing and it'll still show the shape. Wait, hold on a second, bro. That does not look like a legal convex. Okay, maybe it is. Oh, that triangle is illegal. That's not a legal triangle, bro. What the fuck is Blender exporting this shit? Wait, what? How did I manage to fuck this up, bro? I just had to make a cube. It's concave. Yeah, that's not it's not legal. For sure it's not legal. Oh, I think it's because I made like maybe like an N-gon sort of situation going on here. And it just decided to triangulate it like a fucking loser. Actual bozo. Because if a shape is even slightly concave, then the whole thing I think gets fucked up. Okay, see, this is legal. This one's legal. This one passes. This one passes the sniff test for sure. That is so fucking convex. I've never seen a more convex shape before. And it's fucking cooked. I mean, like, what else do you want me to say? It's fucking absolutely fucking fried. It's kind of closer now, though. But we still are cutting across. It's kind of close, but, like, there's still something funny about it. There's still something funny about it. It's one... Yeah, it's like the tiniest percent concave. It's hard to tell. It's hard to tell. If I change that, it shouldn't change anything. Yeah, it's completely fried. Alright, I think I fucking have to give up. I don't know. I tried. Shit. Yeah, that's diabolical. Oh wait, hold on a second. I didn't have that to A. Oh wait, that shouldn't matter though. That doesn't matter. It doesn't. Yeah, I feel like there's something really stupid that I'm fucking missing. Like, if found is false, then we have to add it. And we set the count to 1 for the counts. Jarvis, fix this for me. Jarvis, wrap this convex hole. Jarvis, I need you to wrap the convex hole. Can you do this for me? Please. Please, Jarvis. Wrap the convex hole. Jarvis, you need to march this down. This isn't Jarvis marching. Are you saying that I should Jarvis march? Just give up? Just give up and go back to Jarvis marching. Pack it up. Pack it up. This is the big leagues. It ain't made for you, bucko. Is that what you're saying? I feel you on that one. I've never wanted to march a Jarvis more than ever in my life than right now. Let's look at the Purdue PowerPoint again. Let's just give it a shot. Create facets. Remove the visible facets if PR is outside of CH. How do I check if PR is outside of CH? Do you know how to do that? Do you know how to do that? Can you tell me how to check if PR is outside of CH? I would love to know. If PR is outside of CH. Yeah, I'm looking at their shit, and to be honest, like it's exactly what I got going on, brother. Maybe I'm getting the first points fucked up, but it looks like a tetrahedron to me, bro. It would be fucked up, like mega fucked up, by the way, if something up here was wrong. Like at the beginning of the stuff. Let's see the formulas. Furthest point from the triangle. No, this is furthest point from the line. B minus A, and then AP is P minus A for each point, and then you take the length of the cross of these two divided by the length of AB. Only if Jarvis was here? Yo, Jarvis would clean this up for me stat. Pronto. If cross is 0, then there is no triangle. Well, there is a triangle, so we don't even have to worry about that. We already have this that says probably fucking really bad. I don't know. That's the edge case right there. That's the edge case. Alright, so we find the normal. We once again 0 best dist. And then Jarvis don't want to talk because he's out of tokens. Fucking get the clanker to help me. Is that what we gotta do? Yo, clanker. At this point, fuck it, bro. The P minus A in the normal and take the Fabs F. See, who knows if this is correct? You know what? Let's do something here. Let's not take the Fabs F. Criminal. Bro, yeah, it's about the same amount of fucked up. It's about the same amount of fucked up. I bet you Jarvis knows all about the convex holes. Yeah. That's his forte. Maybe not this. But that would mean that it's duplicate and it can't be duplicate. Yeah, it's nothing. Maybe what if we just fuck it, bro. Only one edge per triangle. Yeah. Can't do that one. Can't do that one. You think it's gonna fry generating bistro? I think it's gonna fry in the good way. That shit is gonna fry. Need to start caching more. Catching these W's. Fuck, man. It's weird how that changes things, putting it behind the thing. Oh shit. Wait a second. 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 Wait a fucking second. This is dangerously close to working. That's scary. That's dangerously close to looking good. Holy shit. It's dangerously close. It's dangerously. It's almost complete. It's almost complete. There is something off. Okay? We're missing a few triangles. Also, there's some funny business going on at the bottom. The bottom layer. Fuck. Shit. I have a feeling that the problem is actually now that we fuck. I think the problem is that we don't know how to check if this point is within the hole or not. We can just use grok. The grok slop. How do I check if it's outside the hole? Maybe that's just guaranteed if it doesn't have any visible faces. That might be just guaranteed, because if it has no visible faces, then that means that it's inside, I think. So that much is guaranteed. fuck, bro. I think we may have it, but we're fucking it up somehow. Shit. It's forced on every model. Did you do the bistro? And it loaded instantly? Nice. Fuck. How are we missing a little bit? We're missing a little bit. We're just missing a couple of pies in the oven. Your house? Well, that's cool. I'm glad that's working. Said 32 to 64. The Jarvis overview. The Jarvis overview. Why did this before this work? Maybe we should take a look. Maybe that's why it's important. Is that works when it's before that other thing. It's taking a bit? Yeah. Are you trying with 32 to 64? Yeah. Hole in the seas. I am deceased. I am diseased. With 3K meshes with 4 million polygons. That's a lot of baskets in the oven. They put baskets in the oven, right? Yup. Alright, let's try taking the fabs off of this business. Yeah, that fucks it up. That fucks it up for sure. For sure. Do the fabs F on that. I don't know if it does it internally. Oh yeah, it's the same thing. Hey, what's up, Max? It's alright. I'm doing alright. I'm working on something. And it's okay. It's so close. I can taste it. Still making that world engine. I kind of got to a stopping point with it, and then I was kind of bored, so no. Not really. I'm working on a new engine, working on collision for it right now, and hull decomposition. "32 steps, 12 min try." Yeah, I don't really get. I don't know. I get to points with projects where I just don't like them anymore. They just are fucking boring to me to work on them. Yeah, that's just a bunch of garbage that it's reading. Yeah, I was just gonna check if it would possibly have those things in it, but yeah, I should do 100% do off. Oh, this is without the offset, without the offsets. That didn't go well. Yeah, the offsets are definitely the way to go. Just it's just really just one array, one flat array that you can just like sort left and right. Yeah, that's what I do. Just the leaves get their own vector, and I just store the start for each node. Well, this is fucked. Yeah, I mean, I'm looking at it, but I don't see anything anymore that I can change. That's all the triangles that we make, yeah. I wish that there was a way that I could see what triangles we make, but then we later delete. I want to see if we are making the final triangles that we don't see. But how am I going to draw that? Well, what I can do is instead of doing any of this, I could just literally keep the faces without changing the indices. And as you can see, we don't have faces on those spots. We're simply missing that one, that one. So we are simply missing some. So it's not the fact that we delete them or that we don't have them. It's just that we never make them. A couple of them. So I'm not sure. Something I want to make absolutely sure of is that we have the points. Yeah, let's just do this. Let's do the points again. God, well, this is fucking disgusting. This is I want the verts. Oh, we have the verts here. Alright, I'm gonna go to the wireframe VAO now and go to draw points again. And we'll just init it to vec3. Does that seem to have the full thing? Let's make sure by actually rendering the whole thing. Yeah. That is all the vertices, so we're definitely getting that. And then if we get rid of that and then we I kind of wish that there was a way that we could draw the there kind of isn't a way for us to draw both. It would be really nice if we could, but we can't. Fuck off. You can tell that I'm getting to the end of my rope here. Can you fuck off? My fingers can't reach for whatever reason. Oh wait. Wait, why is that? Oh, it's because I am rendering the full thing and not just... The whole point was I wanted to see just the initial stuff. So this is our original thing. I almost like wonder. Yeah, I almost wonder if like I'm being stupid and uh I don't know how to judge a convex hull. Yeah, I don't know. It's close to working, but I'm just wondering why. So, for instance, this point just doesn't find this point. Why? Bring him 10 more issues to solve. Yeah. Yeah. That is how it goes. Much better to solve the solutions than solve other non-solutions, huh? Much better. I'm letting it slide too much. Limit subs further, maybe. Is it still going for the bistro? Maybe this is the convex hull, even though it's missing faces. Maybe that's fine. Maybe as long as I have the points, it's. Don't you need the faces though? What's the point of just getting the points? But also we have a duplicate point in there. And the bottom is kind of fucked. So we have two or three extra faces. and probably duplicate points because of it. So it's not perfect, even if that's what it's supposed to be. Maybe I'm stupid for expecting it to be all filled in faces, because then that would just be the mesh anyway. I expect it to fill over the sides though. But I'm not sure. The definition of a convex hull is the points. But I'm not sure. Oh, good. All right, yeah. I guess I'm gonna peace out. I'm gonna figure this out tomorrow. I want to watch the fucking. I need to watch the BLG T1 series before it gets spoiled for me. So I'm gonna figure this out tomorrow. I don't know. I probably like am slightly misunderstanding the algorithm somewhere. But once I get this, the rest is the easy part, I think. Well, I mean, then the decomposition part is kind of hard, right? But GJK after this will be fairly simple, I think, based on like what I've written down. It shouldn't be that hard. But yeah, this is a pain. All right, yeah. Let me know how that ends up baking. I'm tired. I feel stupid because I just sat here for so long today, just like trying to get it, and then I didn't get it. So I feel stupid, but whatever. Something might be up. Yeah, you might have infinite recursion or something. Maybe not. Maybe not. Yeah. Oh, it's going now? That's good. It might be because it goes down the tree and then up the tree, you know? You feel me? It loaded? Well, that's good. Eight steps doesn't sound like a lot, to be honest. I mean, are you doing one mesh? 8 steps seems really tiny. Like, not a lot of steps. Yeah, that's basically whole meshes are probably going to be in leaves, no? Oh, each mesh gets one. Oh, I see, I see. Each mesh, yeah. Yeah. I thought you were doing one over the whole thing when you said bistro, but I guess you're talking about every single mesh in bistro. I get it. I get it. I get it. Let's try using the ABB center. Same dealio. Same dealio. Except the top is gone. Rigid caching system. But don't you just build it once? Maybe that's a stupid question. Oh, I'm fucking cooked. I can't fucking type right now because I'm tired. $32 4 takes forever. Yeah, I mean four is pretty tiny depending on the mesh, I guess. Well, caching for new inits. Okay. Okay, let's see what A and B have to say for themselves. Huh? Let's see. I want to see if we have any duplicate points. Am I printing out the points still? Yeah, let's not do that. It's only done 2. Yeah, I don't see any duplicates in a row. That's what I'm looking for. I see duplicate points, of course, but they have other points on the other end. You know what I want to try? Maybe we just check A and B. Nah, that's an abstract art piece. Fuck. It was worth a shot. It was worth a shot. Maybe a little bit closer. Maybe my epsilons are too big. Nah, I doubt it. 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 32 and 4 though, that's small. Four tries is small, I feel like, right? Depending on the mesh, I would understand why. I feel like you could parallelize it per mesh though. You think the CPU is too slow for this? I did say that building it on the GPU would be better, but yeah, I mean yeah. I mean the GPU is better for like 99% of things. It's just a pain in the ass to write. But you also save the upload costs too, so it's a win-win. Unless you're doing a linear BVH though, it's kind of hard to parallelize, but you could parallelize the meshes themselves. Like just do a mesh per thread at that point. That would probably be fast. I don't know. And that's pretty trivial to implement. It's just literally copy and paste the code. Right? Fuck. Yeah, I feel like depending on the mesh, you know. having trouble waiting on the big ones. Yeah, I mean, for things that have fine, you know, fine stuff. Oh shit, that changed something. Wait, what? Hold on a second. What is that? Yeah, I feel like you should try it on the GPU though, for sure. Generate your SCF with the BVH. Yeah. Whoa. What the fuck? Okay. Oh, and now it's back to what it was. Fuck you. All right, peace out. Peace out. All right, thanks for hanging out. Fuck, it's back to the same thing. Okay, well that's my cue. God damn it. Yeah, that was just a bug. It was just straight up a bug with my allocation thing. Yeah. Yeah, that's fucked. All right. See you guys later. Peace out.